crypto cities. I'm sure you've all read what's going on here, but small recap, it is going to be a generative kind of city planning images using Grasshopper and Illustrator. If you couldn't get Illustrator for some reason, you can also, we're not going to be showing Inkscape, but you could use it alongside as a free alternative. And then we'll be, Andrew will be showing you how to make a crypto wallet and get this set up as NFT. So I'll give an introduction of you, Andrew, who is a principal at Matsis and professor at University of Houston. And Andrew Kudless is a designer and artist based in Houston, Texas. In 2004, he founded Matsis, an art and design studio exploring emergent relationships between architecture, engineering, biology, and computation. The work of Matsis has been exhibited internationally and is in the permanent collection of the San Francisco Museum of Modern Art, the Centre Pompidou in Paris, and Prague Center in Orleans, France. His work on Confluence Park won a number of awards, including a 2019 AIA National Honor Award. In 2019, he became the first American designer to contribute to Louis Vuitton's Object Nomads collection. Andrew is also a professor of architecture at the University of Houston, where he holds the Bill Kendall Memorial Endowed Professorship and is the director of the Advanced Media Technology Lab. And thank you for coming here and doing this, Andrew. And
Yeah,
before we get started, I just want to remind everyone that, as the messages was saying in there, everyone learns at their own pace. So if you can't keep up, don't worry. We can't stop, too long and too often on every little thing. And that's why there's also a recording afterwards. And if you have questions about the webinar, please ask them with the Q&A box. No, you can't use Photoshop instead of Illustrator. Someone's already asking questions. Yeah, no, you can't use Photoshop. You need a vector and some specific stuff there. So, yeah, not everyone learns at the same pace. So, just try to keep up if you can, or just watch it. Totally up to you. Ask questions in the Q&A box, so for us to keep track of, because they sometimes get lost in the chat. And and afterwards you'll get, as the email we sent prior says, you'll get access to recording and all that fun stuff. And just last disclaimer, we're not responsible for the crypto laws in your countries. So if something doesn't work, if something's illegal, if something's blocked, there's nothing we can do about it. And if you lose money for incorrect setup or something like that, there's also nothing we can do about that. So just a disclaimer, we can't do anything about that. So it is what it is. And I'll hand it over to you now. And I'll be here in the background if you need anything.
Great. Thanks a lot, Mike.
Yep.
All right. Let's see. All right. Welcome everyone. It's really exciting to teach so many people online. We've all probably been doing everything online for 2 years now, but to work with 100 people intensively like this is exciting for me. All right, so just to give an overview of the next few hours, I'm going to give a lecture on drawing, generative art, and architecture for maybe 45 minutes. I'm going to try to go as quickly as I can. And towards the end of the lecture, towards the end, I'll take a break a little bit and start going into Grasshopper, and then we'll kind of go back to the lecture a couple of times as needed to go over some of the crypto stuff towards the end. We'll then get into the Grasshopper tutorials. As it says on the website, it's meant as a intermediate or beginner to intermediate workshop. I'm not going to go over the bare basics of how to install any software like Rhino or Grasshopper or anything like that, or how to like add a component to the canvas. Those are all really basic things you can find elsewhere. And I'm going to go pretty quickly though too. And the focus is not to teach you everything in Grasshopper. The focus is specifically a few different kind of tools and processes that I found very helpful in my own workflow. Different plugins that I find really helpful, not just for drawing, but just in general. There are certain things like groups and clusters and things like that that are really good to know about. We'll take a 10-minute break in about 2 hours. We'll come back, we'll do more Grasshopper. And I just want to let you know, and I think you've all downloaded the files. The files are pretty big. I have a pretty beefy computer, and it takes about 30 seconds for my computer to calculate the file. So on like a tiny laptop or something like that, that might not be that powerful. It might take a couple of minutes. I'll show you how to deal with that and how to just kind of gradually work through. There are a lot of really good ways of working with Grasshopper that can like reduce the processing time, and so you don't have to kind of sit and watch your cursor just spin forever. We'll take another break, and then in the last couple of hours, we'll be talking about just exporting things from Grasshopper. This might be really basic for some of you, but I think it's just helpful to kind of understand the workflow to get things to Illustrator, and then how to export them to images. And then we'll be working on creating a wallet and funding that wallet, and then minting on a platform called Taya, which actually it's been around for a while, but it just renamed itself like 3 days ago. So you might not be familiar with it, but it's kind of the latest evolution of the kind of hen or Hiket Nonk ecosystem on Tezos. And then we'll have time for the end for Q&A. All right, so I'm going to go pretty quickly through this lecture because I want to get to the Grasshopper stuff. So for a number of years, I've been really interested in drawing, and that was really surprising to me because I've always been really bad at drawing. In school, I didn't draw very well, and because I was so bad at it, I actually, this is in the 1990s, I kind of started using computers to try to like keep up with my peers. And I think it's been really interesting what's been happening over the last 20 or 30 years in relation to drawing, because for hundreds of years, architecture has been like the foundation of architecture, you could say, was its relationship with drawing. I think this Robin Evans quote summarizes that really well, that like architects have to deal with how to take three-dimensional space and kind of compress that into the two-dimensional plane, but then at the same time, how you take the kind of abstract rationality that you can develop within a two-dimensional plane and bring that back into three-dimensional reality. So, this is, for probably many of you, you've never seen a room like this, but with slight differences, this is pretty much what my studio looked like when I was in undergrad. And so we've gone really, really far in 30 years or so, to the point where we're at now, where not just are we, already obviously in a model-based paradigm, but now even the models are being created kind of automatically from scans and things like that. We have robots that are drawing, floor plans at full scale on the floor for contractors. So I guess the question always comes up of like, what is the point of drawing? Why should we still be engaged in drawing at all? And I think the way that we in the world of computational design, I would say when I know I've been teaching it and many others teach it, and when we practice it, I would say the act of drawing is often not in any way a focus in a number of ways. I'm not going to go into each of these, but basically, I mean, the one that I think summarizes it the best, the idea of design to production, that drawings are kind of seen as an intermediate step that should be eliminated. That the traditional process of an architect doing a drawing, that drawing going to a fabricator, having the fabricator do shop drawings, and then having something fabricated, that the idea of design to production, that the architect is kind of directly creating the files that run the machines. There may be drawings in there in some way or another, but the drawing itself is not like the focus of the creation, I'd say. So I'm not going to go over all of these, but I would just say in general, either it's the design to production is, I'd say, a major area within computational design that we've focused on for the last 20 years or so. And then building information modeling, where of course there's a lot of drawing and building information modeling, but the drawing is simply a kind of something that comes at the end, I would say. That the model, as the building information modeling suggests, that modeling is centered and the drawings are algorithmically being produced from data within that model. And they're primarily being produced for legal reasons, for getting permits and things like that. So a lot's been changing, I would say, in different areas, from the modeling side and data kind of based modeling, things like test fit, up codes where your model is being checked against the local building code, so that potentially in the future you wouldn't have to even get a permit in the traditional way, getting a set of drawings and handing them over to an official, that your model, that the building code could be embedded within your model, so that if something were to happen, you were do something that wasn't correct, you would know immediately and you could then get it signed off if you fixed it. Or things like Photogram, where the digital model is overlaid over reality, again, bypassing the need for physical drawings or digital drawings. Or like game engines that, again, that architects have been trained at reading drawings, but clients are not trained to read drawings. And it's often very hard to communicate to a client using traditional architectural drawing. So renderings have taken over, I would say, not just the communication with the client, but often just even the communication within an office with the kind of advent of real-time rendering. So again, the question of why draw and why do a workshop on drawing? So this quote from the architect Kelly Baer, I think is really good. I'll just read it. The drawing becomes a catapult for invention, leaving behind the expectations of convention, buildability, or financial burdens. The drawing is a proto-document of something that is not quite finished, an act still underway in the eye of the author. So I'd say like the drawing is a perfect location for experimentation, for an idea of sketching. And I don't mean like just hand sketching, but the conceptual idea of sketching. That you take an idea and you kind of experiment with it very, very quickly. So if you expand that idea of sketching, that it could be a hand sketch, it could be a digital sketch, it could be an algorithm. But the point is that it's a very kind of fluid thing, and it doesn't have to adhere to kind of buildability or other types of conventions. So I want to jump back a little, because at one point, almost, I don't know, like probably 8 years ago or something, maybe even more now, after teaching kind of computational design to students for about 10 years, I had a student come up to me and say, when I asked them to do something in Grasshopper, and they're like, oh, well, I didn't learn Grasshopper, in year 2 because, I just don't like twisting towers. It's not my thing. And so I just didn't learn it. And I was just kind of, first annoyed, at the student, because like, I spent a lot of time developing this curriculum and you just decided not to learn something. But second, after I got over that kind of initial frustration, it was more like, oh man, that's a failure of my own pedagogy, that for 10 years I'd been teaching like kind of the case studies in computational design, like the Swiss Re Tower in London, or a project by Zaha or UN Studio, or something like that. And it was all of these kind of famous double curvature panelized projects. And even though I wasn't myself all that invested in those projects, the fact that they were built, I thought was a good way of teaching computational design, that students could see something in the real world and then see the technology that was used to create it. But what I failed to understand was there were a lot of students that would just disengage with the technology because they weren't into that style of architecture. And it made me realize that I'd only been teaching Grasshopper in relation to a certain style of architecture. And I needed to find a better way of teaching it, because I thought like that these tools are amazing. And it doesn't matter if you want to do a twisting tower or if you want to do something else entirely, you can still use these tools to help automate a lot of tasks and to help you, I'd say, structure your design thinking in a way that is difficult to without these tools. So I decided to find a better way of teaching Grasshopper and computational design and fabrication and robotics and other things, that rather than focusing on like these built examples of architecture, I'd return to kind of early conceptual art and computational art from the 1950s and on. So projects like this by Solowit or Ellsworth Kelly, that these were people who were artists who were not using computers, but they were, I'd say, using computational thinking to develop their artwork. So like different permutations of the incomplete open cube, or using random operations to reorganize a painting. There are others around the same time, like Manfred Mohr, Werner Moeller, who were computer programmers who understood computer languages and plotting machines and things like that and had access to them. And they began exploring those tools to make art. So people, they weren't like trained as artists often. They were trained as programmers, but they saw the potential in using software and using generative techniques to create art. A couple of decades later, the kind of early 2000s, late 1990s, there were people like Casey Reyes and others who started to develop specific software like processing and later P5.js and many others that could be used to create what kind of a digital generative art. And I'd say basically the tools became much more accessible. And I'd say Grasshopper is one of those tools that it makes programming much more accessible to the average user. And it helps kind of, it's like I'd say a stepping stone in some ways. You don't have to go all the way to programming in like a text-based programming environment, but it's a visual programming environment that allows a way of thinking that it approaches kind of what you would need to actually write software. A little bit earlier, in the 1980s, 70s and 80s, there were a number of architects like Peter Eisman, Daniel Libeskind, and many others who are often referred to as kind of the paper architects. But I like to think of it less about just the medium that they were using and more the ideas of like that they were procedural architects, that there was a very clear kind of script that they were using. And, you might look at the Libeskind drawing there and not think that there was a clear script. But I think there was. There was a process that each of them went through, and that was rigorous, and it was focused on two-dimensional drawing as a way of discovering new possibilities in architecture. So over the last decade or so, there have been a lot of exhibitions, books, symposia on kind of this reemergence of drawing in the profession. And again, since drawing wasn't really my thing in school, it was always modeling and fabrication, things like that I was into. I kind of refound drawing, I would say, in the last 10 years, partly because of my desire to kind of go back to ways of working from, like I was saying, these early conceptual artists, and finding ways that I could teach computational design through the world of conceptual art and drawing. Um, so with Adam Marcus in California at CCA, the two of us decided to to create an exhibition of how architects use drawing and computation in current practice. And we commissioned 24 drawings, this is in 2017, for the first drawing code show. And then 2 years later, we decided to do another show, and we're currently working on the third and final show of 48 new drawings for a total of 96 drawings that should come out next year. And we basically created a series of rules that each architect had to follow, that had to be square, it had to be black and white, it had to be orthographic, and the drawing had to be about how they use drawing and computation. And it was a great exhibition, I think, say if I can say that myself. And it made me kind of even more invested in exploring ways of using drawing in my own practice. So I very much see if the typical definition of drawing and the reason that a lot of people give you to do drawings, like hand sketches, is that it's like a direct connection between your mind and your hand. I would say like computational sketches can be a direct connection between your mind and a machine. And that machine can be virtual, it can be just an algorithm, or it can be a literal machine, like a robot. And I've developed this way of working over the last 10 years where I often will explore a certain algorithm in a very sketchy way. Like literally sometimes I'll just be sketching the algorithm. Actually, I don't even know if this can show up on the screen, but just the other day, all blurred out, never mind. But I was drawing an algorithm and then trying to understand the different parameters of that algorithm, how I could encapsulate certain parts of it into functions that are reusable and things like that. And these develop over many years. And sometimes I will come back to them and find new uses for them. So for instance, this one that I started, I don't even know anymore, like 2015 or something like that, 2016, where it's just a way of teaching myself, oh, I'm forgetting the plugin. But there's a plugin to do kind of loops in Grasshopper. Here, let me see if I have it somewhere over here. An enemy. And it was, so I just really did it to teach myself an enemy, and then that turned into a way of first just making drawings. I then realized how I could turn the toolpaths for those drawings into 3D printed toolpaths. I could use it to develop this memorial at a cemetery in Northern California that was then cast in concrete. I could create drawings and mint them on NFT platforms. I could create weird island animations. You know, this was like a 2-hour kind of fun little thing. Or this was a rug proposal for Louis Vuitton. But it's basically all using the same algorithm and just different variations of that. So for that first exhibition of the Drawing Codes project, in addition to curating it, I had also kind of commissioned myself, told myself that I also had to put a drawing in the exhibition. And because I was very much dealing with just getting all the drawings from people and framing them and hanging them and all of that, I had kind of avoided my own drawing and doing my own drawing. And I thought, oh, it'll be easy. I'll just do, you know, like kind of pull up one of my old drawings and do something new for it. But this was happening right between when Trump was elected in the United States and when he was inaugurated, that the show opened like, I think a week or two before he became president. and just this constant refrain of, the wall, in all of these speeches and everything just made me very worried, and it reminded me of this, like, a kind of a medieval warlord or something like that. And I wanted to think about the idea of a wall more, and how a wall could be less a division, like almost by definition a wall creates, geometrically one side and another, so that it kind of separates one space or one territory from another. And I wanted to think about like other ways of thinking about what a wall could do. And I had this idea for a walled city that, unlike this, where there's kind of like the territory outside the wall and the territory inside the wall, I wanted to find a way that you could develop a wall to make a walled city that basically confused the nature of wallness or sidedness. So in Grasshopper and Kangaroo, sorry, this is old, low resolution animation, but developed a really simple algorithm for growing a wall, and made some rules for it where it couldn't intersect itself, and it couldn't go beyond the border of the dash border here of the city. And I kept on trying to grow it until it was about 10 miles long, and did different iterations of that to try to get that 10-mile long city. So then I had the problem of, how do you turn this squiggly little line into something that actually a person would be able to understand the drawing and understand that it was a drawing of a city, not just a squiggly line. So I went to another algorithm, which was just Google's auto search suggestions, because I had this big long snake, but I had to like somehow represent roofness to it. So I was like, well, what does a roof look like from above? What might be on a roof? And after thinking about a couple of different ideas, I realized that there were like many ways that a roof could look, and wanted to really explore how to like kind of chop up this snake and create like a diverse program that is accessible like across the entire roof of the project, and you could move from kind of one program to another. Excuse me. So I just started typing in the word rooftop and then the letters A through Z. And of the first 6 suggestions, if one of them was more architectural than the others, I would select that, write it down, and develop an algorithm that would somehow represent in drawing form that program. If in that first letter there wasn't anything, I would then, type a second letter after it. So if I couldn't find anything with just A, I would type AB and then AC and AD and so forth until I found something. So there was a lot of human choice in that as well, and selection. So over the last couple of years, I've then been kind of doing this more. So it started with this walled city project, but I started thinking about how I could develop kind of a library or an atlas of cities that each explored different algorithmic ways of thinking about form. And I'm not trained as an urban planner, urban designer. I'm not thinking of these cities like really even in those sense. Like none of these are real. They're not. I wouldn't put them into utopian or dystopian or anything like that. I'm not proposing these. I very much think of them as, first, a way to explore an algorithm, and second, a way to kind of jog my own imagination about what cities could be, without kind of reservations or preconceptions of what urban form might be. So often I look at these after I've made them, and I then start to think like, well, what kind of geologic process or economic system or political system would have created a city with this form? And it's just a way of thinking kind of beyond our own, I think, conventions. So I guess, I don't know when it was, sometime in the summer, I don't even remember now, maybe in the fall, I started making more of these and then selling them or minting them on uh, an NFT platform. And it's been interesting way, like I'll talk more about NFTs later specifically, but it's just been a way for me to like, it's a hard thing to explain in a way, like why am I doing this? Or why it's not economic, I would say for me, it's not like I'm doing it all for financial gain. It's that I think it has like, we're all used to posting things on Instagram, but Instagram, it's I think highly problematic for a lot of different reasons. That you're putting your content out there for free, and then what you get in exchange for it is like some number of likes and some visibility, and that's useful to some extent. But Instagram or Facebook or Meta, whatever they're called, are they're making money off of your content. And so I was primarily engaged with the idea of NFTs as a way to share work. And if people really liked it, they could buy it. But if they didn't, it's still freely available online. And I think that's like a really interesting idea. What behind, I mean, there are a lot of problems with NFTs, but I think one of them is that they do turn content into assets, but those assets are simultaneously free and simultaneously not free. And that you can right click on anything and download it. You can look at it on a website for free. But if you really love it, you can pay for it. And I think that brings up an idea of patronage, which I think is very interesting, right? That it, Instagram, like your clicks, like your likes of something aren't helping the artist or the architect or the designer, whoever it is, that much, other than maybe visibility. But with a lot of, like, I've spent more on art in the last year than I have probably my entire life. And that feels really good that I'm like supporting artists that I like. And it's not for me about the ownership, maybe, who knows, like some things might be more valuable, some things will go to zero, but I'm not thinking about it as a form of investment. I'm thinking about it as a form of patronage, as a way of like thanking artists for creating something that I like and for bringing something interesting into the world. So these are just a couple of those cities. You can see they're really detailed. I tried to, come up with different ways that I could sketch roof forms, roof detail. What was an algorithm for how people might gather together? How do you represent that in a through code? When you zoom in really far, you can see they're very abstract. On one hand, it's kind of like a typical architectural drawing, and the other, it just ends up becoming hatch patterns and line weights and so forth. So around the same time in the last year, I was asked to kind of be a guest on One House Per Day, a project started by Andy Bruno, which, if you don't know about One House Per Day, there's the Instagram address at the bottom there. You should definitely check it out. He basically, unrelated to the pandemic, because he started it in January 1st, 2020, right before the pandemic started, that he decided to create a constraint on himself on his daily practice. And he said, I'm going to design one house per day. I'm going to do a axon, a plan, and a section of it every day. And he did that for 365 days. And after that, he decided to open it up to others. And he asked me to do 7 days of it. So I decided to kind of push this idea of generative architectural drawings. So I've been working on these generative cities, but decided to kind of jump scale entirely and push it to generative houses. And as you can see, kind of constrain myself, that they couldn't be, they were kind of fit within a circular plot, let's say. They had to be all done generatively in Grasshopper with no kind of initial drawing or like manual drawing. There were some like furniture placement and things like that I did after it was all baked. And then they all had to be produced with an AxiDraw plotter using only two pens and one pencil. So for each of those houses, though, there were 49 different alternatives that I looked at and then selected from each one of these. So these are the 49 for each of the 7. And then detail a little bit, and just to kind of go into more detail about it, that just like the cities, the idea was to explore like 1 or 2 algorithms, usually just one algorithm within each house. So in this case, it was looking at tile systems and how they've been used within architecture. So I developed these 7 tiles and then used Grasshopper to array them in kind of infinite number of ways. I chose one of those, and this is based off of many other people in history, and also currently looking at tile systems from like artists, textile artists like Annie Albers, Oscar Stahlberg, the game designer. If you haven't looked at Townscaper, you should definitely download Townscaper on Windows or Mac or iOS, anything, I think, at this point. Because I think it's one of the most fun and cheap video games out there. And I think it's actually the future of architecture. I mean, this one kind of looks like some crazy, I don't know, European hill town or something like that. But if you get beyond the style of what's being shown, it's the math and the geometry, the computational design behind it is incredible. And then my own work, the tile system I developed for Confluence Park, these are the concrete pavers. There are just 4 pavers, and then they kind of array aperiodically to create this kind of never-ending, meandering system of tiles. These will work. Well, the videos won't work, but anyway, we're going to do videos of the AxiDraw drawing them, but you can see they are all drawn again. So then coming up with like, how do you translate a drawing that's done digitally into a drawing that's done physically using a robot? All right, so let's see where we are. Yeah, 45 minutes exactly. So I'm just going to start talking about what we're going to do today then. So this is in the files that you've downloaded, there is a folder. Let's see if I'll bring it up. So there's a folder called Rhino Grasshopper. And actually, before we get to that, there's a folder called Drawings Illustrator. So this is the finished drawing. It's really huge because it's like a 1 meter by 1 meter drawing. And it has, I don't know, hundreds of thousands of lines in it. But if you want to open up kind of what's on the screen, then that's where it is. And you can kind of zoom in and see the detail and kind of understand what we're going to be working on. So this city started with an idea where I wanted to basically look at how I could use these flow lines or field lines and use those, that there was something about these kind of eddies, these circular areas that are like concentrated energy. There was something about these within a city, that they were potentially places to gather, and that as the lines kind of radiate out from them, they become kind of voids within the city. So there is kind of like an urban grid on one hand that I'll show in a moment. I mean, you can see it here, right? That it's a gridded city that you could, just like any normal kind of grid city, you could easily move from one side of the city to the other across the grid, or at least vertically you can. Horizontally, it's a little bit more circuitous, but that there's this other kind of overlaid system on top of it that's a series of voids. So these are just a series of, these are basically the functions within Grasshopper, like the building blocks or the different chapters or groups, whatever you want to call them, that we're going to kind of work through today. So the first one is just, how do you work with, field systems and get lines out of it? The second then is how do you offset those randomly into a series of what I'm calling these like voids in the city that will eventually become kind of parks. Then there's the other system, which is the street grid. And I wanted the street grid, again, I wanted it to be both random in both directions so that the spacing of the cells is kind of uneven in both X and Y. And that you can kind of move through the city vertically, let's say, or in the Y direction more than you can in the X direction. Those then get offset into a series of blocks. Those blocks get intersected with the voids to create either buildable areas or park areas. Both of those park areas and built areas get further subdivided by a series of kind of random lots. So you can see those are then the built lots, and then there's the park lots. So the lot lines end up becoming kind of sidewalks within the park. And then there's, I wasn't happy with the way that these, the field lines kind of move through, like it seemed like the grid was kind of overpowering them in some way. I wanted the primary reading in some ways to be of the flow through the city along these lines, despite the grid. So developing these really weird crosswalks that emphasize the kind of connection between the flowing lines. So basically the street would be painted in a different way wherever the flow field intersects it. Then basically a lot of entourage stuff, trees, shadows of trees, different shades for the canopy of the trees, hedges or bushes or something along different sidewalks within the parks, building shadows. So there are a few things that are like three-dimensional, but like I never even look at the 3D model. Like I'm just like extruding something and then immediately flattening it into a shadow. And then developing more entourage to help represent roofness, whatever that means, that the roofs need some diversity of features on them, like AC units, structure, texture, tiling, whatever you want to call it, that might be on a roof, skylights, things like that. And then finally, and maybe most importantly, but also computationally heavy, are the people. So I think in the file, there's almost 25,000 people that are arrayed in different ways across the project, but you can see primarily the vast majority of the people are kind of populating the centers of the attractors in the flow field. So coming up with an algorithm of like, how do you, like, what's happening in these? Like, is it people performing music? Is it a protest, a speaker? And coming up with ways that you can visually represent that, like which way would a person be facing if it's a performance versus which way would they be facing if they're just walking in a group along the road or standing in a park talking to a couple of friends. All right, so then here's the final version of that. And then also in the folder I've given you, there's a folder called guides, and in that is a PDF called graphic standards. And that just shows, of course, you can get those from the Illustrator file, but just so you can see, this is what I used for this particular drawing. I wouldn't say I'm very consistent. Like if we go back to these other, oh, maybe that was too far back, but these other drawings, like I'm not always consistent with the color of the shadows or the fills or anything like that. I'm always kind of experimenting with it. And that's kind of part of the process for me, that it's just trying to understand what looks good and how do I use these tools to develop these kind of hypothetical urban forms. All right, so just to finish up kind of the overview, just a couple of slides, we'll come back to this later, but at the end of the day, we'll talk about installing a wallet. We'll be using Temple Wallet, which is one of the most common ones on the Tezos blockchain. It's really easy to install, and also Tezos is very inexpensive. Like the transactions are very inexpensive and things like that. So it's a good place if you're just getting started. It's much, I'd say, easier in some ways than trying to engage the world of Ethereum, which has much if if you make a mistake, it can be costly if you don't know what you're doing. Whereas it's only a couple of pennies if you make a mistake with Tezos. I'll show you how to fund the wallet by sending from an existing wallet, and that's kind of like a chicken and egg problem. Like, how do you fund a wallet if you don't have any other wallets yet? Hopefully, once you get a little bit of funds in your wallet, and you can hopefully then sell things, your wallet will start filling up with funds that you can then again use to make more art or do whatever you want with it. But you can also, I won't be showing this how to do it from Coinbase or Binance or any of the other crypto exchanges. And again, just to reiterate what Mike said at the very beginning, I have no idea where you are in the world or even what state. In certain states, certain platforms in the US are illegal. In certain countries, some platforms or some blockchains are illegal. I'm not giving any advice on that, as far as you have to figure out what's best for you. And similarly with taxes and all of that, I am not giving any financial advice. Finally, you can also there are places you can buy crypto just with a credit card and then transfer it to your wallet. And then we'll mint a piece on my with using my wallet. Finally, I just want to let me see, go back to that guides. There's also this other guide. Just let me bring it up here. It's a series of links and gives you a little bit more information on some of these things, like the Temple wallet gives you the link for the wallet, blockchain links, like if you want to learn more about the specific blockchain we're using, Tezos, and some of the different kind of tools that you can use to explore that blockchain. And then links to a bunch of different platforms. We'll be using Tea, which kind of grew out of Hen, and then there were a bunch of other kind of clones or near clones like object.com. Versum just was created about 2 weeks ago, or launched 2 weeks ago. FX Hash was created early November. So a lot of these are very, very new. And then a couple of other tools that kind of independent developers have created to help like appraise your collection or see sales in a more rapid, kind of transparent way. Other types of analysis that you can do on either your own collection or other artists' collections or other collectors' collections, I should say. All right. So let's go to Grasshopper. I'm going to open up Grasshopper, or open up Rhino, I should say. And sorry, I haven't been looking at any of the Q&A stuff. Let's see. All right. All right. So I'm going to open up. I'm going to go into the Rhino Grasshopper folder and just open up Citybase 1000 meter. So there's nothing in this file. There are no any layers, no hidden layers, anything like that. It's all it is just a metric file in meters with a grid that is pretty big, just as a good way of getting started. So I'm going to open up Grasshopper. Too many plugins installed. All right. So just to maybe start at the end, I'm going to open up the very last file called City 02, clusters telepathy. So it's gonna, number one, what I want you to be seeing here, as it opens up, look at my layer palette. It's gonna take about 30 seconds to open up the entire file, but you can see I'm not doing anything, but layers are starting to be created. Okay, all the layers are created and we should start to see something in the Grasshopper window. Now, I wouldn't, especially if you have not a very powerful computer, this isn't the way I would actually open up the file. Like I said, if your computer's kind of has less power, it might take a couple of minutes. And a really good way of opening up files that you don't, let's say, trust, or if you don't know, is like, is this file, like if you didn't create it, or even if you did create it, but you're worried that maybe that file is going to like crash your computer or something like that. I'm going to just open up a new document real fast. What I do when especially if like I've just crashed something and I need to reopen that file that just crashed, what I'll do is middle click on the canvas and disable the solver, and then open up the file while it's disabled, because then it will open up super fast, because nothing is being calculated. And then you can go and selectively turn off the things that are taking a lot of time, so that when you re-enable the solver, they won't calculate. So I'm not going to do that now in this particular case. Sorry.
Andrew, I don't know if you
Yeah.
want to turn your camera off.
Oh yeah.
For
Thanks.
resources.
There we go. Thanks.
Yep.
All right. So I'm going to go back to this so you can kind of see. So this is what we're going to end up with at the end of the day. It's a pretty big file. You know, you can see it took about 30 seconds for it to calculate, and I don't know how many, how much geometry is in it, but I'll go towards the end here, and yes, there's 24,814 people. So if I zoom in, you can see, all these little people with their shadows and so forth. So I don't want to like operate on this file, especially like if I change anything at the very beginning of the file, everything downstream from it also has to update. So it'll take, 30 seconds to recalculate every single time. So we're not going to do that, but I just want to talk about a few, we're going to kind of start at the beginning and just step by step create things. But I just want you to know where we're heading. So this uses a few different plugins that we're going to talk about. And if you don't have the plugins, let me just show you for a moment here how you get some of those plugins. So if you opened up the Grasshopper file and you get all of these like warnings, like don't have telepathy, don't have Clipper, human, I think are the only three. I could be wrong, but I'm pretty sure those are the only three. The way you get that in Rhino 7 is that you type in package and package manager. And this is a great new way of adding plugins. Like there was a very annoying way of doing it previously, and sometimes you still need to do that, of like going to foodforrhino.com and then downloading and what's it called, unzipping, unblocking, putting into your library folder and so forth. That was annoying. So they finally developed a package manager, and this is where you can find, I don't know, at least 100, maybe more plugins that are more recent plugins that have been kind of upgraded to the new package manager. So if I go to human, for instance, there are two different plugins called human. One's just human and one is human UI. They're both developed by the same person, Andrew Human, play off of his last name, a different spelling though. And you can see that if you have a check mark next to it, it means that it's installed. So if I click on this, it'll tell you what the name of the plugin is, who the author is. You can see Andrew Human's name there, what the installed version is, and what the current version is. So if you could change, you go back to an older version. I think all of my plugins are, oh, it looks like Finch. Yeah, you can see here that it tells you, like, with a check mark, I have 1.18 installed, but 1.19 is available. So this is a really good way to know, like, are your plugins up to date or not? So I could go to Finch here and then press install, and it would install it, but I'm not going to do that right now. So again, the ones that we're going to be using are Clipper, Human. I'm going to try to show Hops, but it's a really incredible plugin, but it's kind of buggy, I would say, still, and it doesn't always work in the way that you would want it to work. I think, am I not seeing Human, Clipper? I think that's everything then. All right. So once you do that, install, maybe you should restart Rhino just to double check that everything's installed. If you open up the file and you're still getting some type of warning message, that probably means that it wasn't installed correctly. And you should try to figure out why. Telepathy, it just shows up on the parameters tab, the very first tab, and it's these two, it only has two components. There's sender and receiver. Human has its own tab called Human. And then Clipper, for some reason, always shows up at the very end. I've never understood what the order of the plugins of the tabs are, but Clipper always shows up at the end for me. And it's a very small plugin. I only use two of the components in it, but I use them all the time. All right, so again, this is the very end product, and it's huge. We're not going to be able to do all of this in class, and I've tried to structure this as a way that you can use this file immediately, but you can also, like, kind of go back to earlier steps and just kind of follow along some of the things that I'll skim over today. So what I really like about, let me just maximize this for a moment so you can see it a bit better. So there are a few things that I'm doing here that I'd say make it look less like a normal Grasshopper file. The first thing is there aren't wires like everywhere. So if I like open up, I'm just going to open up the first one, the field. This is much more of a standard Grasshopper file. You have the wires going everywhere. You have like little, what are these things called? I don't know. I've forgotten what they're called. Relays. Sorry, the tooltip wasn't coming up. These relays help you move data across the file and in a fairly organized way. So if I go back to the final file, though, you can see that there's a lot of these bluish purple things. And if they have an arrow going from the right side, it's a sender, a remote sender. And if it has an arrow coming in from the left side, it's a receiver. And basically what these are they're very, very similar to wireless components. So for example, I'm just going to demonstrate this really fast. Let's say I wanted to make a rectangle. A rectangle. And I want to be able to use this rectangle lots of other places in the file. So I don't know, let's say I want to add some random points to it like this. Now, if I just hide my Grasshopper for a minute, you can see down here, there's that rectangle and there are those green random points. So, but I want to be able to do this like way over here or something like that. And I don't want to have this wire going all the way across. So from, I don't know, at least 12 years or longer maybe, Grasshopper has had the ability to change the wire display. So you can right click and you can go to wire display, you can go to faint, and that makes it a little bit smaller, which I've never used, or hidden. And hidden is nice. It makes this little like Wi-Fi symbol, and it's fine. If you click on this, you can, whenever it's selected, it shows you what it's going to. But it's pretty inefficient. It's very hard to tell where this is coming from. And if that's like a variable, like the frame, you want to be able to use that multiple times in multiple places in your file, it's not easy to do so. So I'm going to bring this back to the default. Just move it back here for being able to see it all together. So with telepathy, you just can type in sender, SEN is enough. And then I'll say like order. You name it whatever you want, but think of these in the programming sense as variables. So they have to be unique names. So you can't have multiple variables with the same name because it gets very confused then. So if I plug this in, I now have a component that is sending wirelessly this curve all over the canvas. And if I want to get a receiver for that, I can just double click on it. And now I automatically get a receiver, and I can plug that receiver in, and it already has that wireless component. So what's cool now is that I can, if I wanted to, somewhere else in the canvas, I could grab a receiver, right click, go to keys, and you can see a lot of variables in this file, but I'll go up to border and now plug that in. So it's a way to like access data wirelessly in a more traditional programming sense. So for any of you who have done any programming, you can like say like X equals 5, and then you can call X other places. You don't have to like draw a wire, between things. Like the program knows that there's a variable named X. So that brings up, so telepathy is great in that it kind of brings that type of working to Grasshopper, that way of working where you have the ability to bring things all over the file without having wires everywhere. So it's, and what's nice about that is that it tells you very specifically, what's going in. And then, other places like this is something like I wanted to be able to use elsewhere. So I give it a name. And if I click on this, you can see it's now being used way over here. And there's the vertical streets input or receiver. So some of these get used a lot, like building outlines, you can see gets used all over the file, for many different reasons. So it's just a way to clean up your file. And by doing so, it allows you to kind of separate things into what we traditionally call functions in programming. So, groups, oops, I didn't group it all properly there. You probably know groups already, but just in case you don't, let me just delete this one. That here are some components I've made. I can just select those and then do either Control-G, or I can use the middle mouse button and go up to this green blob, and that creates a group. Once it's in a group, I can just move that whole thing around. You can create groups of groups. So for instance, this is one group, this is another group, this is a group that contains both of those. So it helps me to like structure my thoughts this way, but it also helps me to structure the input and output. So a very common thing that programmers do when you're creating a program is you start writing at the very beginning of your program, like the different variables that you think you're going to need, that you declare those variables like as an integer or a real number or a string or something like that. So, obviously when you're working, you don't always know all of the things that you're going to need, but I find it very helpful, at least within sections, to work this way where, excuse me, I can start to create a list of parameters and then send those throughout the file so that when I'm working, I can just write the name of what I want. So if I'm like, okay, I need I need a receiver, and then I need it to be the border of the city or something like that. And that brings me that right away in the file. So yeah, being able to arrange it all in one place is not just, I think, useful for you as a way to help structure your thoughts of like, here are the inputs in a way, like this Turk or cyan area here, like these are the inputs, not all of them, but most of them in the file are here. These are like the machines like doing the work, all of the operations. And then I have all of the outputs down here in pink, so that I know I can at any point just go and grab, bake some outputs to the file on a certain layer and things like that, which I'll get to a little bit later. All right. So the way this file is structured and the way that the Grasshopper files are structured is that, like I said, we started here at the very end, but I just wanted to give you kind of an idea of where we're heading. But we're going to start with step one. Actually, we're going to start from, I think, scratch, from nothing. But if you get lost at any point, you can kind of just go to wherever we are in this area. It's going to be, I'm not going to, since I'm recreating a lot of things, things are going to be a little bit different. And I'm going to try to use clusters and telepathy more than I did in these intro files. But basically these files, the first 6 files here, step 1 through step 6, they don't use clusters, which I'll get to in a moment. They don't use telepathy. They do use groups, but just not too many of them, I would say. It does use human to do a couple of things, but it's there. I would say the city 0 or city 0, 1 are like more basic, and then it goes to much more advanced at the end. But we're going to try to add some of these kind of more advanced things in as we recreate the files together. All right, so I'm going to open up a brand new file, and let me try to arrange my screen here so that we can see what's happening at the same time, hopefully. Okay, so the first step, let me go back to the, where is it? So the first step was to create these field lines. But maybe even before that, the step is to just create a box. So I'm going to create a rectangle. Gotta spell rectangle. And you can see as soon as I add that rectangle to the canvas, it's already making a rectangle. Because I know this is in meters, I'm going to type in 500 and make that both the size in both directions. And just to kind of demonstrate the telepathy, I'm going to immediately make this into a parameter. So I'm going to make it this. I'm going to call the slider city size X. And then I'll just copy that and paste it into the name and do the same over here. So immediately we're already getting kind of a disconnected thing here. So I'm going to copy that and rename it city. Well, I guess so this is, I would say, don't do this. I don't copy and paste them, because you see what's happening now. You have sometimes you might get confused. You might have like two variables named the exact same thing, and now they're both going to one thing. So I wanted to show you that to tell you not to do it, because you can mess yourself up there. So I try to always create the senders from scratch. Oh, need to copy. That way I know it's not like connecting to anything else. All right, so now if I zoom out, I should have a 500 meter by 500 meter rectangle there, which I do. All right, so I'm not going to do this for all of everything, but I just want to show you ways to help organize your files. Like, it's not just about communicating your work to other people. It's, I would say more importantly, is communicating your work to yourself. When I start working, I often, if I'm like really in this like flow state and just creating a Grasshopper file, I don't worry about organization too much. That's not the way my mind is working at that moment. It's more about, it's just like problem solving and finding creative ways to do something. And I'm not worried about how, the aesthetics of the file, how well the file is organized, anything like that. However, what I try to do is like stop every hour or so when I'm working, or sometimes every, 15 minutes or whatever makes sense for, like, if I finish something that's like a good solid block of, like, functionally a solid block of code, that it's like I've accomplished what I want, but it just looks like this rat's nest of wires and everything. It's just crazy. Often if I take like 5 or 10 minutes to organize that and group it and create the proper telepathy things, or create clusters or something like that, it really helps me later on. It's really bad to like create a file with like hundreds of components with wires everywhere, because by the time you're done, you don't even know what you really did. And it's really hard to restructure things at that point. But I think it is valuable to have this like balance between like unstructured creativity, where you're just creating things, and then like breaks where you try to name things properly and things like that. So I like using the scribble command just to like create nice big labels for things like that. So I want to create another sender now, which will be the city border, because I know I'll use that lots of places later on. All right, so that's like the first block. That's really, really simple intro Grasshopper stuff. All right, so let's get to the more interesting things, the flow field. So under vector field, there are a bunch of different commands for creating a field. So I'm going to start to pull some of these things out. I know that I want to create spin forces. And you can see if I zoom in, by default, there's just one of them being created at 0, 0, 0. So I need to do a number of things to this, because I want them spread all over the file here. So the first thing I want to do is I'm going to get some random points out. So I'm going to turn on another really great plugin. You don't have to have it for this, but I like it a lot when I'm teaching. It's called Bifocals. It's actually created by the same person that created Telepathy, in that it adds a automatic label over every single component. I love working in icon mode with Grasshopper. Some people hate it. So if I go to display and turn that off, your file might look something like this. I hate turning my head sideways and trying to like read what, figure out F spin means. I don't know the components like that. I have used them now for, I don't know, 14 years or something. So I'm really used to the icons, and that tells me more about them. But I know for when students are learning, like knowing the names is helpful for being able to search them and things like that. So bifocals, you can download it. I don't think bifocals is available in the package manager yet, but it is. You can install it from Food from Rhino. All right, so when I added this populate 2D, it automatically creates a rectangle of, I think, 10 by 20 or 20 by 10. But we want it to be the size of the city border. Now, I know this seems weird because I could just draw from here to here. That seems really easy, but I'm just going to grab the city border instead, like that. And now you can see by default, there are 100 of these. So I'm going to maybe make a slider that goes from, I know it's always important to create sliders that have proper ranges. It's really easy to create sliders that start at 0. And I just recommend for most cases, you don't want a slider that has a minimum of 0, because it's really easy to break your file that way. Like, you might accidentally divide something by 0, or if it's a size, and that somehow by going to 0, by sliding the slider towards 0, you're actually exponentially increasing the number of things that you can crash Rhino really easily, or Grasshopper really easily. So in this case, I know I want at least one kind of vortex in this city. And I'm showing you a way of creating sliders if you don't know. Of course, you can always grab a slider like this and right click and go to edit and change everything about it if you want. But it's a lot faster to just type in a number and then 2 periods, or you can write a less than symbol. I'm used to just doing the 2 periods. I want it to currently have a value of 10, but maybe I want it to go up to 40. And I'll call this attractor count. Plug that in. So now I have, some number, or I have 10 of them, and they're spread around somewhat randomly. And the randomness is a combination of 2 things. Part of it is a seed, but also it's like a, I forgot the name of the specific algorithm that David Rutten implemented for this, the programmer behind Grasshopper, but it's not truly random, in that if something was truly random, some of these points would be much, much closer. I think it's called like blue noise or something like that, where the points are random, but they have some space around them. Like they're not getting too close to each other, but they're not also in a grid evenly spaced. So I'm going to create another slider. And it's just going to be, I'm going to give it a value of 500. I don't know, somewhere in there, 592, doesn't matter. And I'll call it tractor seed. So if I move this around, the points, I still always have 10, but they're just 10, they're different places of those 10. So now that I have those, I can add the spin forces, but you can see they're pretty small. So the next thing I'm going to do is to make some random, well, if I were to go down the list, strengths would be next, but you can't visually see the strengths. So I'm actually gonna just jump ahead to the radius. So I want some randomness to these, so that they're not all going in the same direction, and they're not all the same strength, and they're not all the same size. So the way I'm going to do that is to go to sets and get the random component. So I want, like I said, I'm going to do random radii. So I want however many attractors I have, that's how many different radii I want to create. And I want those radii to maybe, let's see, I want them, I'm not really sure. I'm going to say, I don't know, let's say 50 is the smallest value and 100 is maybe the current value and 500 is the largest value. So this is going to be the minimum. So let me write that in here. Attractor radii min. And maybe let's see. Yeah, let's try that. And then finally another seed. So I tend to just use seeds that are somewhere in the 100, somewhere between 0 and 1,000 basically. And plug that in. And now if I plug that in, you can see that they are all getting bigger. Maybe 250 is too big. Maybe I'll put it at 200 or so. And maybe I want some of them to be a little bit tighter, like that. So now they go between 50 and 200. So I want to do the same thing for the strength, but slightly different. So I'm going to just copy these two random components. Actually, we'll do it the other way around, just to keep things somewhat ordered. Always change your seed between these different things. Now for the strength, this S, I want it to, I'm also going to use a range, and I don't really know what a good strength is. So I'm going to put a value of, I'm going to put a value of 11 in. So the way, if you just type a number, just if you don't know this, probably many of you do. If I were just to type 5 in, it automatically creates a slider between 0 and 10. If I create 11, it automatically creates a slider between 0 and 100. So it always goes, it finds where the number you input is between the different powers of 10. And because 11 is in between 10 and 100, it automatically makes the maximum go up to 100. So if you type in, like I did, 11.000, I get the same slider that goes between 0 and 100, but now it has 3 decimal places in addition to that. So that's a way to kind of automatically create sliders with within certain ranges. All right, so I want this to be the attractor strength. And the way that the strength works is that if it's positive, you can see there are these little arrows here, and the arrows are going counterclockwise around the point that they are, the center of that attractor. So if they're going counterclockwise, it's a positive strength. And because by default right now, the strength is 1. And if it's negative, it goes counterclockwise. So what I'm going to do is plug this value of 11 and then right click and go to expression and make that negative. So negative X. So now I have a range that goes between negative 11 and positive 11. And I will plug that into the random component. So now you can see I get that I have 10 values that are all between negative 11 and positive 11. And I can plug those in. So now you can see this one, whatever one I happen to be on here, you can see the arrows just got reversed because it was one of the negative numbers. So again, the reason I'm doing this is with this vortex, I want there to be, if they were all going in the same direction, you'll notice that in the flow lines. So by having some of them be small and weak and going clockwise and some large and also going clockwise or going counterclockwise, you get kind of a more diverse kind of flow field. All right, so we now have our flow field, or we kind of do. We have actually 10 different fields. So they're not interacting with each other yet. So in order to get them to interact, I need to go back to vector, field, and merge fields. So now I just have one field with 10 elements. So now when things are calculated, it's not just calculating 10 different fields. It's like they're now kind of like one field or one interactive weather system instead of 10 different weather systems. All right, so the next step is to actually get the sample lines. So if I were to go back to the field and get field line, the inputs for this, the first is the field that we want to evaluate. So that's easy. This is the field that we want to evaluate. The point that we want to evaluate that I could, for instance, if I just, I'm going to make a point. Just going to select a point there that I could add that point in. And you can see it's created this curve around that. And if I select a different point, it creates a different flow line. But I don't want to have to select points in this. I want them to be automatic. So I'm going to delete this and create another set of points. So I'm going to go back to vector, populate, and I'm going to get another city border. And I now want to create some number of them. And I think by the default of 100, I think will work, but just to make that so you can see it, I will plug it in. And then I will create another seed for those. So you can see here are the points, the 100 points overlaid on top of the field. And I want those to now be where I am sampling that field. So the way this flow field thing works, I'm gonna hide, well, I think you can see it. So what happens, there's N, which is steps, and A, which is accuracy. And you can see I'm getting this 637 milliseconds. That's taking, it's bright red. You might not see this in your file. If you go to display canvas widgets profiler, if I turn that off, you can see that the profiler disappeared. Go back to canvas widgets, turn it on. This basically, it only shows up when things are taking a lot of time, and they're red if they're taking the most time on your canvas. So it's relative. Like right now, my canvas is pretty empty, but by far this is taking up way more time than anything else. So I don't need them to be that accurate. So I'm going to do something slightly differently, which is to reduce the accuracy. So if I let's see, maybe make it, I'm going to make it go from 0.01 with the current value of 0.1 to a maximum of 1. So if I plug that in, when I plug this into A, watch what happens to the profiler. Well, that didn't do much, actually. It should have gone down, I think, more than that. If I now increase that, two things are happening. You can see the time is decreasing slightly, but also I'm getting way more field lines here. And what's happening is that, think of these as samples. So this is, that first point is the first sample, and then it's saying go in like by 1 meter by that vector, and now sample it again, and then again and again and again. And I think we could probably see this if we get the control points for these. Yeah, so maybe not exactly a meter, but you can see that if I decrease this, they should get closer together, like that. So I'm gonna, keep it at 1. That'll decrease things a little bit. And I also don't want them to be this large. I actually like them when it was a lot smaller. So I think by default it has 1,000. So I'm getting 1,000 curves, or 1,000 points per curve, and I have 100 curves. So a lot of points here, you can see. So what I'm going to do instead, I'm going to reduce this to around 60 instead of 1,000. And that brings me back to kind of what they were, or at least close to what they were in the beginning. That I don't have, they're not all over the place. They're not getting too close to each other. Sometimes they do get close to each other randomly, but that's fine. That's actually what I want. So now you can see instead of 600 some milliseconds, it's only taking 40, which is still the most of anything on the file, but much, much less than what it was before. So I'm going to create another sender. So we might use this later. Call field lines. But I also want to trim some of these, and let me just clean this up. Turn these things off. This is a good time to, again, restructure your file. Control G for group. This will be another group. All right. Maybe do it like that. All right, so we have these. So the next thing that I want to do is trim them so that they only go to the edge of the city. So I'm going to go to intersect and then trim with region. And again, I'm going to get my receiver component and grab the city border. So that's the region I want to trim with. And I want to trim with that border. So it's showing you both the curves inside and the curves outside. So what I often do is just grab another component. I just want the curves inside, and then I turn that off and turn this one off as well. So now you can see that all the curves are just trimmed with that border. All right, so now I want to introduce Clipper. So there are a lot of different offsetting commands. Actually, I think Mike, you created a couple of them. But if I just type in offset, you can just see there's, I don't know how many are there. Let's say 10 or 12 or something. There's lots of different offsetting. Some of them are curves, but it's like very confusing sometimes of like which ones you actually want. And offsetting often fails. It's just notorious within Rhino, even before Grasshopper. Offsets fail all the time. So I found Clipper to be really useful. It has its disadvantages, but Clipper is it comes from a C++ library for super fast offsetting of polylines. And it's what like Illustrator uses for like the Pathfinder and all the Boolean stuff, things like that in Illustrator. It turns everything into a polyline. So it's not great if you want to preserve curvature of your curves. But in my case, I don't really care if they're curves or polylines. So it's actually, it's a good use for this. What's really nice about it is that it outputs things, what they call it the contour, which is the outside offset, and H are holes, which are the inside of the offset, which I'll show what that means in a moment. So if I plug this in to that, and let me see, what are the, I'm just going to copy some things here just so I don't have to, you don't have to spend time watching me type things. But so I have two sliders, one called field line min offset and field line max offset. So I want to randomly offset each of these by some value between 5 meters and 15 meters. So that, or that's not exactly true. I want them to be either 5 meters wide or 15 meters wide at their maximum. So the way the offsetting works with this, which if I just plug this in, so all of them are being offset by 5 right now, which means that the total width of this, as you can see, if you look at the grid in Rhino, that this is about 10 units wide, or it should be exactly 10 units wide. So that's not what I want. I want them to be 5 units wide. So I need to divide all of these by 2. And if you just want something like a constant, I often just use 2 slashes like that, and then you can put anything you want, text or numbers, and then enter, and it automatically creates like a little mini panel that for me, it's helpful. I use it as a way to tell myself that this thing shouldn't really be changed. Whereas if I type in 2 and it turns into a slider, that makes me want to move the slider around. So if you don't want your user or even yourself to change something, then I think putting it in a panel, I mean, you can obviously, I could come in here and change that, but it's like a little bit harder to, and it's I think better to do it this way. All right, so if I do it like that, now you can see they're all exactly 5. But I want them to be either or somewhere between 5 and 15. So this will set up a range. or a domain. And then I can grab a random component, and this will be the range that they're selecting from. And let's see, what do I want to do here? So this is going to, I want however many we have here, I want, so I think I'm just gonna flatten these. Yeah, there's no reason, yeah, no. Okay, so this is good. So I do want to flatten them so that they're just one long list, in this case of 102 curves. But let me see. Well, I'll purposely make a mistake here just so you kind of understand how Clipper works. So I'm just going to grab that number 102 for the total count, and then just put some random number in there. So that gives me 102 different offset values. And I have 102 polyline curves. Now, if I plug these in, it may take 10 seconds. Let's see. You can see this is like an immediate, when things take that long, especially when, you have a good computer, you can see like this is not what I wanted to do. Because what happens with, it doesn't happen with most things in Grasshopper, but the way that Clipper works is that it thinks you want, like for each of the 102 curves that you're offsetting, it's offsetting them 102 different distances. So that's not what you want, because that's 102 squared. And resulting in 6,000 some curves. So yeah, I'm not going to do that. So let me just undo that. So the reason it did that is that it thinks you want to do that for every single one, which I don't. So the way around that is to graft them. So now I have one curve on each branch, and if I do the same here, I'll have one offset value on each branch. So now you can see they are, I'm getting, skinny ones and fat ones and things like that. They're overlapping, which is fine for now, but the next step will be to union all of these together. So a couple of other things to point out with Clipper is because it's converting all curves into polylines, it's doing so using this tolerance setting. So if it's taking a really long time and you don't need it to be as accurate as, in this case, 10 centimeters, then you can just increase this to like a meter instead. And if I were to do that, so oops, if I were to go from so this is, if I do this, I think that's its current, or it should have, sped up a little bit. But if I do this, you can see it's getting like, it's like a way to very quickly kind of roughen a polyline. And I don't want that. So I could, probably keep it at 0.1 is fine. I think it was at 0.01. Still pretty sketchy in here, which is kind of, it could be good for certain things, but actually I'm going to delete it. It's only taking 15 milliseconds, so it's not taking that long to have it do it at every 10 centimeters. All right, so there, like I said, there are contour is the outside and H are the holes, are the inside. So it looks like, just so you can see what the difference between these two things are, because I'm going to use them all the time. So these are just the contours, what they call contours, and these are the holes. So holes are what happen when you offset like a closed or a curve that ends up becoming kind of interior to another curve. So let me just maybe demonstrate this really. Sorry, just can't see with Grasshopper on top here. So if I just have like a simple curve like that, and I import that curve, and I'm just gonna grab another offset component. Okay, so if I offset it, it doesn't, there number first, you can offset single curve or open curves or closed curves. And that's what the CF is closed and O is for open curves. So for open, I can change, you can see it, so it has a butt ends to it or square ends or round ends and so forth. And at the moment, there should just be one polyline coming out of this and nothing coming out of the holes. If I were to take a different curve, let's say like that, and offset it, I'm getting one curve on the outside and one curve on the inside. So the one on the outside comes out of contour, the one on the inside comes out of hole. There's a bug in the Clipper thing that I don't know why they haven't fixed it, because they update it all the time, but they never update this thing. So this is a closed curve, but notice it's getting this little chamfer on the end. If I go here, it's set to square, not miter, but basically in the code somewhere, they have these two reversed. So if I go back to miter, it actually squares them up. And if I go to square, it miters them. So that's just a little thing to be aware of, but you can also have them rounded and so forth, just like that. Anyway, so sometimes I want the things on the inside and sometimes I want the things on the outside. And this is something that all of the other, as far as I know, all of the other offsetting commands, like the default offsetting command that's just in curve over here, it doesn't, it just gives you all of the curves and it doesn't tell you which ones are inside and which ones are outside. All right, enough of that. Make this bigger again. Take that off. Okay, so next step is to combine all of these. I'm going to also turn off the some of the stuff. It's always a good habit to turn things off as you go so that you can just see what you're working with at the moment. All right, so I want to combine all of these into one thing. And well, we'll see what happens, but I don't think I really care about these fully enclosed ones like this, because these, I probably just care about the outside one. I want that whole thing like to be a park or something like that, since I always know I want kind of like the center of these to be kind of open as much as I can. So I could, let's see what happens here. If I go back to Clipper, the only two components I use in Clipper are polyline offset and polyline Boolean. So polyline Boolean works very, very similarly to the shape Boolean, or region Boolean, I should say, region union. I wish they could just use the same terminology. So the way region union works is if I flatten these, and I plug these in, and now I'm going to turn those off, turn these off, that it's unioning all of these shapes so that they are now joined, together. So that's what I want. It took a while. The region union tends to take a while. So I'm just going to compare how to do this with the polyline Boolean. So in order to make it do the Boolean, the way that this works, whereas in the vanilla Grasshopper, normal Grasshopper, there are different commands for difference, intersection, and union. the way that Clipper works is that it's just a different type of Boolean. So you can see there's 4 different types of intersection, union, difference, and XOR, which I almost never use, but it's basically, it's like, is the space in neither one curve or the other. So for most of those, you need curves going into both A and B, but for union, you just need them going into A. So right now, it's set to intersection. So I can right click on this and go to union. And let me just turn this one off so we can see the result. And you can see it doesn't really seem to do anything for some reason. I don't know why. Sometimes you need to take off the even odd. And that seemed to work for most of them. You can see a lot of them disappeared, but we're still getting some intersections here, which is annoying. Sometimes plugging in a plane, even though there should be a default plane in there, sometimes that helps. Sometimes the tolerance, but it just seems like for this case, unfortunately, even though this one took 15 milliseconds and this one took 574, it looks like the normal Grasshopper one, not the Clipper version of Boolean, is working better. So if I turn this off and turn this back on, you can see that it is capturing all of the intersections properly. All right, so I'm going to use that one instead. Sometimes you just need to know what the bugs are in the software to know why something isn't working, or to know what tool to use. Okay, so I think that's the end of this section. I'm going to turn this into a sender, and I'm going to call this field line polygons, because I'll be using those to difference things out later on. All right, let me just clean this up a little bit more. I'm not going to put names on all of these because, again, you can just go, I should save this. Oh, actually, I have a plugin installed that's really, really helpful that I just showed, but it probably wasn't clear. So I have a bad habit, and you just saw me do it, of opening up a new Grasshopper file and then just start working and not saving for a few minutes. Now, Grasshopper has a really good autosave feature, but that autosave feature only works if you've saved the file once. I hadn't saved the file at all yet, but notice it has a name. If I cancel here, if I look at the top, it says unnamed, and then it has the date and time. So I have a plugin called, I think it's called autosave, that's been installed, that as soon as I open up, if I go to file new, it automatically saves the file to some place in the hard drive. So that if it crashes, I think you can go to, where do I find it? I think it's file, preferences, files, and then autosave. You can find where the autosaves are there. Anyway, they may have updated Grasshopper to do that anyway, but for a couple of years, that plugin was the only way to do it. So if I go back to that, I actually want to save it, it's somewhere in my file directory that I know where it actually is, rather than in the roaming folder. So I'll save it here. And this was field lines. All right. Let's see. So we're coming up on 2 hours in. So that was when I thought it would be a good place to stop. So why don't we take a break for 5 minutes, and we'll start again, whatever 5 minutes from now is, wherever you are. All right. All right, just a quick break. Take a little bit of a longer break. The next one. All right, so as you can see, this is, we haven't done very much here, but hopefully you all have now a good introduction to how to use telepathy and some other things, some of the basics, just so that we can move a little bit faster and get to some of the other big things that I want to talk about. What I'm going to do is I'm going to start another file here, and I'm going to copy in a few things from basically everything that we've just done, plus the grid. Let's see if this works. There it goes. I don't know why I didn't copy it the first time. So what I did was I just grabbed all of the parameters from like the big file at the end. That'll just make it a little bit easier to copy things in as we go. And I also copied in, if I'm going to turn off these field line stuff. So let me go back to what we were just doing. Okay, so that's where we left it. We had slightly different sliders and things like that, values for the seeds and things, but this is close enough to what we had. I'm going to skip over the next step because what it gets you, and we can experiment with it, and I'll show you what it does, but I'm not going to go through it. It's not that it's that long. It's just that it's not, I'd say, too advanced as far as like, you're not going to be learning too many new things in this section, but I do want to show you kind of what's happening in it. So, because I think it does do a couple of interesting things. So I wanted this kind of uneven grid, but I also wanted it to potentially be totally even. So like, how do you structure something so that it can be either completely uniform or completely random, depending on a slider or a couple of sliders. So I'm going to just show you kind of what it does. So we're past the field line section into the grid parameters. So first of all, if I change the random seed, you can see that the horizontal lines aren't changing. So this is just the, probably should have named it something better, but it's just, I guess by width, I meant the X direction. And it's just changing those kind of randomly. What the next one down, street random limit, is one of the problems you have, and I'll try to show this to you real quick. If I were to get a random number generator and create whatever that was, 15 here, I'll just copy this. So the same number of random points along this direction, and whatever, some number here. If I were to evaluate that curve along those random points, make sure it's reparameterized. So if I change this, you can see I'm getting all these different random points, but what tends to happen with random number generators like this is that they're not spaced very well. So you can see that there's like, these two that are really, really close together, and that's going to result, if this is your city grid, it's going to result in, blocks that when I offset them to get the sidewalks and, the buildable area and things like that, they'll just offset into non-existence, right? They'll just go away. So I didn't want to use a fully random number generator to create the streets going in the vertical direction. However, I wanted to be able to have some randomness to it. So the way I did that, if I delete this, the way I did that is I have this limit switch here. Wrong section. So street random limit. If this is all the way to 1, I believe it's like fully random. And if it's all the way to 0, it's fully uniform. So like these are, it's now exactly whatever 15 divisions are of 500 meters. So basically I'm limiting how much how random it is with this factor. And so if I were to change the seed, like I just found one there. Where was it? Since it's fully random at this particular seed, I'm getting these two really close together. And that's not quite what I wanted. So by putting it at 0.75, I'm limiting how random they can be, that they never get too small, basically. And the way, oops, wrong, zooming out in the wrong window. The way that that happens is that I'm creating a number, here, let me try to step through it. Creating a line across the bottom there, and then evenly dividing it by the number of divisions that I want, and then finding what the distance is basically between any 2 points, and then using that to help set the random range that's possible. That it's either going to go basically at fully random, it has the ability to go all the way from this side to all the way from this side, basically half the distance on either side of any one point. And then I scale that by this factor. So if it's scaled at 1, it remains exactly if it's at its maximum, it could go anywhere within that range. But if it's at 75, it's maybe like in that range. And if it's 25 or something, it's maybe in that range. So that allows it to, or you can see like that the points are somewhat random, but not totally. And then I create the vertical streets from that. And again, if I go back to this, that they're totally evenly spaced and then very randomly spaced. And by putting it somewhere around here, 0.75 is where I found a good sweet spot where you get some really skinny blocks, but they don't totally disappear. All right, so getting the horizontal streets, the ones going in the X direction, that took a lot more time in there because it's basically the exact same operation that I just did, but now doing it, instead of just doing it once, doing it for 15 different ones. And then in the end, what I really wanted to do is to reorganize these, not just as lines going between them, but by shifting lists around and then reorganizing them with this merge component of actually creating full rectangles. So if I were to bake these, you can see that when I select it, it's not just a line going horizontally or vertically, but it's actually like a block. And so that's like it's like the block center line. It's like center line of street, basically, but all the way around a block. So that will help me offset things in the next step for creating street widths and sidewalks and buildable areas and things like that. So let's do that then. All right, so this next step, I want to grab those blocks, or first of all, let me delete everything that's here so I'm not, yeah. Let me get a receiver and I will get the block center lines, and I want to offset those using Clipper. And I want to offset them based on a street width. And I think I have that also as a variable already set up, street width. And so that's the width of the street, but I want, it's going to offset on either side of that center line. So I actually want half of that distance. So I'll just get a division component and divide by 2. And then I also want the sidewalk width. And I think I already have that set up as well as a slider. So let me find that sidewalk width. So I'm going to add that to this, clean things up a little, and then offset these. So then you can see that gives me all of the blocks offset kind of nicely. So, and again, because the clipper gives you both the outside and the inside, it's really nice. And then I can now just grab only the offsets that I want, only the interior offsets like that. So maybe I'll get rid, or not get rid of it, but turn off the center line so that we can see that a little bit easier. All right. So there are a couple of different operations here that we want to do next. If we go back to the PowerPoint, we've done these 2 steps. We've done these 2 steps. So the next one is to get the buildable area and the park area out of the 2 spots. So I'm going to focus on getting those 2 right now. So I want to find essentially the intersection of the field lines, or the field line polygons. So let me go find those. Field line polygons. And I want to grab the Boolean. Oops, forgot to put the bifocals on. That will help you all. All right, so this is the buildable area, and I want to find the intersection of the buildable area and the field lines to find where parks go. So I'll put those in. If I turn these off, now we see only the buildable areas, or not buildable areas, but like the sections of each block that intersect the voids. I basically want to do the same thing. Now, I should mention again, it's a little hard to see this, but by default, it already used the intersection. So that's why I didn't need to add anything into the Boolean type. To make that more literal, I can always just type in the number, the index of that, so that we can see that it's doing something different for the next thing. So the next thing that I want to do is get the built area. So again, these are the blocks. Let me hide this one for a minute. So these are the blocks. So then what I want to I want to find the difference. I want to subtract these field polylines from the blocks. So again, by default, it's set to intersection. So if I hold my cursor over that, that difference is number 2. So just copy this, plug in 2, like that. And now we have the blocks minus anywhere there will be parks. Yeah, that was pretty easy. All right. So the next step is to actually subdivide each of these into a series of lot sizes, basically kind of random lot sizes. And there's lots of ways we could do this. Like if we wanted it super regular, we could create a grid within each one of those that's like a uniform grid, and then divide those blocks. I wanted to do something a little bit more random that actually relates back kind of to the history of computational design. There's a computational design, or a creative coder, I guess would be maybe a better term for him, Jared Tarbell. Just go to So let's see. So Jared Tarbell, I don't know when he implemented this, probably close to 20 years ago, maybe not that long ago, but maybe 15 to 20, using processing. And it's a really beautiful, I mean, I don't know if there's going to be volume on this, but it's a really beautiful algorithm that ends up looking almost like fields or cities or something like that, in that there's basically just a line that gets created, and that line keeps on growing until it hits another line. And as it's growing, it spawns new lines that are at some angle to it. So you can see here, most of them, I think they're always 90-degree angles from the original line. And then he's added some like nice watercolor kind of effect that gets kind of bleached out as it gets further away from the original line. So if I, you can see it's continuing to grow. At a certain point, if the line gets maybe too small, it stops growing. But yeah, so it gets this kind of like urban core to rural area very, very quickly. So it was so popular, again, this is like 15, 20 years ago, that David Rutten actually implemented it inside of the mesh component or the mesh tab. So it's, you can even see substrate algorithm inspired by Jared Tarbell. So it's a fun algorithm, and if you probably many of you didn't know it existed and has this long history, almost 20-year history or even longer, to history of computational design. So I'm going to use it. All right, so it has a few inputs. So let me try to explain what these inputs are. So B is the border. So we're going to want to use our block for the border. So let's see, these are our blocks. So I'm going to plug this graphed. So I want basically it to operate, instead of just doing it once over the entire area, I want it to operate I want it to run however many blocks we have, 175. I want it to run 175 times individually and not, cross those block boundaries, because there was no need to have, lots inside the middle of a street or something like that. So if I plug this in, probably something crazy is going to happen because of the default settings. It does. So the number one, you can see that they all look really similar. They tend to, like, maybe it's more scrunched in some versus another, but they all have a very similar effect to them. Two, they all are using, they're all using very similar angles, that they're restricted to, I think, 3 different angles. And I want them to simply be restricted to one angle, which is 90 degrees. They're also using the exact same number. So it doesn't matter if it's a big block or a little block, they all are being subdivided the same number of times. All right, so in order to help with that, you can see that there's a few things here in the parameters. There's the number of subdivisions. So we want this number to be variable based on the area of the block. So small blocks get subdivided less than large blocks. So let's just start with that. Actually, let's start with the angle, because that's the easiest. So I just want them to be 90 degrees, and it's measured in radians. Almost every angle input, if I hold my cursor over it, it says base angle in radians. So I am going to convert 90 degrees into radians, because I don't think very well in radians, and most people don't either, I don't think. So now you can see, let me turn this other thing off so we can see a little bit clearer that they are all now 90 degrees, but they still all look very similar, right? They all have 3 big blocks at the top, all of them, even the smallest ones, or I guess it's 4 going along the top. So we need to change that, which would be the seed. So I'm going to show you a nice command here. The tree statistics gives you a lot of information about a data tree. So let me just move this around a little bit so we can see things. It gives you the address of the tree, the number of items in the tree, and the total number of items in a tree. So for the moment, I just need this bottom one, the total number of items, because what I want to do is to create a different random seed for every single block that we have. So we have 175 blocks, so I'll plug that in there. The range that you use is as big as you want, but most likely if I'm getting 175 tries out of 1,000, I might have a couple of duplicates in there, but I probably won't notice them. If I wanted to make it even more of a chance, have a higher chance of using a non-duplicate seed, I could make this a higher number, but it's probably okay out of 1,000. And then the next thing is I just need to create some random seed, master seed, to control all of them. So I have that, but they're not grafted right now. And they're also not integers. I mean, they'll automatically be turned into integers when they're used as a seed anyway. But it's always nice if you know you need to use integers, then might as well convert them. So the last thing I need to do is graft. And I know for those of you, many of you probably know you can right click and just simply press graft. But just to be really explicit about it, I'm just going to I normally do the right click and graft or flatten when needed, but just so that you can all see what's happening, I'm going to use the graft component and plug that into the seed. So now you can see they all look different, or even if they're not different, they're different enough that I can't tell that let's say this block and that block are the same or something. And if I were to, like I said, increase this to 10,000, there's a much higher chance that they would not repeat. All right. So the other thing that I want to do is that right now, the really tiny blocks are getting subdivided still into 100 little pieces. So that doesn't make a lot of sense because these would be like the size of shoeboxes and not buildings. So the next thing I need to do is somehow work with the area. So I'm going to get the area of each one of these blocks. That gives me a centroid as well, which I don't need now, but sometimes it's useful to have. And I'm going to divide that area by some number. So it's like how big roughly, I mean, it's not an exact calculation here based on the way that substrate works, but basically like how big is the smallest lot? So, I mean, it's kind of up to you, but I think I used previously a value of 200 square meters. And I think I have that in the file as a variable already called lot size. So I'm going to divide this by my desired lot size. And I know 200 square meters isn't very big, and I can maybe change that in a moment. And just in case there are some really, really small lots that are, let's say, I mean, this is pretty small. Just in case I divide something by, you can see here already the second one actually is less than 200 square meters. So that would result in it maybe rounding down to 0, which might be fine. Like maybe I want that one lot to have 0 buildings on it or something like that. But I'm just going to round it up to the next integer. So I can do that by typing in round, plugging that in, and then using the ceiling function, which rounds up to the next integer, next highest integer. So that looks a lot better as far as lot sizes. We're still definitely getting some lots that are like, I don't know, 4 or 5 meters square or less. That's fine. Like there's weird inlets in buildings or backyards that are really tiny, or atria that come down, and or light wells, I should say. That's what I was trying to say, for small things. So we're going to get rid of all of those things in just a minute. Anything that's too small, we'll just delete as a building lot. Okay, but the thing about this substrate that I don't really like is that if I were to bake this, just so you can see what it does, it results in just curves, not in areas. You know, they're not polygons yet. So in order to convert these into polylines, we need to split them. Do this. So as a general rule, I try to work with points and vectors and lines and polylines as much as I can, and then use curves if I have to, and then meshes, and then surfaces if I have to. But surfaces are like computationally the biggest, that they take as the most computational power. So I try to avoid surfaces as much as I can when doing stuff in Grasshopper. I try to only create surfaces at the very end of the process. But in this case, I do need to create a surface because that's the only command that I know of that works really well for this. So I'm going to turn all of these blocks into just a very, very simple, 4-point surface. But I can then use the intersection surface, what's it called? Surface split, to take these surfaces and split them with these curves. And I try not to do this, but I try to do other things when I can. But in this case, I think it's the best solution. So now I can grab, go to surface, get the edges of those surfaces, and then join those. And that will give me, if I hide all of those things, and now if I were to bake these, if I did this all correctly, it now gives them as actual rectangles. All right, so just as a demonstration of where this could go, if you wanted to try something different, like I could put in some other number in here, like 25 degrees, and it will, generate something else. I could also create something, say like 25 and 35, and make it multi-line. And now they, are both using 25 degrees and 35 degrees or something like that. So I'm just going to go back to 90 though. All right. So next step is to basically combine these two things. Well, next step should actually just be to clean the file up as always. So have that there and that there, relatively clean. All right, so then hide these other things. All right, so now we want to find the intersection of these lots with, if I turn these on, I think these are, I should write this. I think these are the buildable areas, and these are the park areas, I think. Gets a little confusing with the bifocals on, where labels start overlapping each other, but it's fine. Okay, so basically what I want to do is I want to find some intersections between these things, of like what is both buildable and in these lots. And it's a little, there are ways to do it, but there's a lot of ways it can fail. So a trick I'll show you, I'm just going to flatten all of these, number one. And then two, I'm going to offset them just a little bit so they're a little smaller. And that will help a little bit. All right, so I'm gonna, like I said, just a very small amount, like 5 centimeters. So if I zoom in here, actually, I think I did this the other way around. I want to do it like this. Now that I saw that if I zoom in, now you can see that there's an inside line, an outside line. I don't care about the outside one. So I'm just gonna take these inside ones, turn these off. So now I can see I just have these inside lines, and there'll be, these small 10-centimeter gaps between buildings, which, based on the line weights of what we're working on, like we'll never see any of that at that scale. Okay, so that gives us all of the buildings, and they're not touching each other anymore, which is very helpful for the next step, where we want to find the intersections of all of these and all of these. So I'm going to go grab again with Clipper. I want to find the intersections of these and these, and let's see what that gave us. Yeah, there we go. So now, like, these bigger building masses that we had before were intersected with these blocks, or lots, I should say, and we now have these areas. Yeah. All right. So we want to do the same thing with the park areas, but slightly differently. So I'm going to hide these, turn on these so we can see them. So these are the park areas, and we want to divide them with these. But with the parks, we actually, if you think of like sidewalks running through a park, that we're going to have sidewalk area versus grass area. So I'm going to grab another one of these, but this time make meter wide sidewalks in these things here. So if I turn this, again, I only want the outside ones, or I'm sorry, the inside ones. So now you can see I have these meter wide sidewalks, and we want to find the intersections of those with the actual park areas. So again, I'll grab this, make a little bit more room here, try to clean things up. Then I want to find the intersections of these and these, which gives us that. So now we have the parks, and we have the buildings. The last thing I want to do in this section is, these field lines that we had up here, that these were these like the things that generated all of the parks, right? So here are the park areas kind of cutting through. So it would make sense. I mean, at the moment, it doesn't make much sense that I have these like really fragmented parks, and you can't really, circulate through. There's no sidewalks going in the direction tangent to the field line. So what I'm going to do is also remove those. So I'm going to grab the field lines again. And I'm going to offset those. And maybe with a slightly bigger, maybe it's like 1.5 meters or 2 meters or something like that. Yeah, whatever, that's fine. So now I have these paths kind of running through, and I want to difference those out. So I'm going to take all of, oops, wrong one. Grab the wrong component. I want to take all of those parks, these parks, and difference out these curves out of them so that there's always a center pathway running through all of these. All right, so these are here. I want to go to difference, which is also number 2. So now we have that. So now you can see there's always this path kind of running through all of those parks. So I'm going to turn off the rest of those. I think that's right. There we go. All right, so now you can kind of see there's like this difference, like the buildings are very tightly packed together, and then the park areas have these kind of wider, either 1 meter or like 1.5 meters roughly, sidewalks running in between them. All right, so obviously there are some issues here though, especially with the buildings. Like if I zoom in, like this is about 1 meter square building and things like that. So I think getting rid of some of these would also be kind of helpful. So I'm just going to go through kind of like a culling process to get rid of these. So I'll get area of all of these blocks and then say, is this area larger than, let's say, nothing would ever be smaller than, let's, I don't know, maybe smallest is 1. That's way too small. But yeah, this on the slider, I'll say 10, and then maybe like 30 or something like that would be the biggest I'd ever want to call. So, so anything smaller than 10, and I'm going to just delete them, I think. I don't think I need these at all. So I'm going to take these and call them by area. So now you can see if I turn these off, I'm getting rid of all those tiny ones that used to be in this corner. So instead of it now being 3 tiny little buildings, it's like a more of a plaza up against this building, like a tiny, still like a little patio against that building. Then, you know, not every building in a city is built. And at the moment, there's kind of like a very Boolean thing. It's like if a building or a lot is inside one of these park areas, it's unbuilt. If it's not, it's definitely built. So to create a little bit more randomness, I'm just going to take some percentage of all of the buildings and say they're unbuilt. So like 25% of the city lots are just unbuilt or something like that. All right, so to do that, I'm just going to take the total number of buildings that we have and get a random number and make some slider. Doesn't matter what the seed is for that. And I'm going to leave the number range from 0 to 1 by default. So I use this all the time to be able to like randomly reduce something or split something randomly. It's basically like flipping a coin, where it's between the numbers, between the random numbers I'm getting are going to be between 0 and 1. And then I'm just going to compare that to some other number between 0 and 1, like 0.25 or something like that. And then use a dispatch component to dispatch these into 2 different lists. So basically 25% of them roughly will go in one list and 75% will go in another list. So it's a really good way to just break things out. So if I look at these 2, you can see basically 25% of the properties, I'll call this vacant vacant lots or something like that. And these are the built lots. So I could say that, you know, more, so that would be 100%. And then this is the opposite, you know, the very few buildings are actually built. So it's just a really simple way of using a random number generator to be like a coin flip, but to like weight it on one side versus the other. All right, so getting very close to the end of this, and then we're going to get to clusters next after we finish a few things here. So, okay, of the lots that are built, I want to randomly reduce these even more based on how close some of these buildable lots are to the center of the vortexes, the flow field. That if I turn these back on, right, these green points are the centers of kind of vortexes, and I want crowds to kind of congregate in these urban plazas in those areas. So I don't want to put a big building right there. So what I'm going to do is grab those attractor points. I can't remember if I have them or not. I do. Attractor points, and get the centers of all of the built lots or the buildable lots that have not already been turned into vacant lots or and haven't been turned into parks or anything like that, but just the ones that are actually kind of possibly or most probably going to be built. I just want to select the ones that are closest to these attractor points and put them into like a special category that I'm calling plazas, where the crowds will begin to aggregate. So I'm going to use under vector closest points. So these are the points that I want to find things from, and I'm going to graph those so that I'm finding from each one of them a certain number of points. These are all the points that I'm searching from. And then I'm going to use, let's say, take the 5 closest kind of properties, and we're going to turn those into something else. So I'm going to just flatten that list of indices. So this gives me a list of all of the indices for each one of those. So I'm just going to flatten those. So I just have a big list of the indices of all of the properties. And then I'm going to select certain properties. So let me take all of the properties and then select just those. And now you can see, if I just turn on the selected, you can see I just have then the 5 closest properties to each of the center of those vortexes. And then I want to also delete these from this larger list. So I can go to sequence, call index. These are the indexes. This is the list of all buildings. So then this is basically the opposite of this. These are the plazas. These are the buildings now. And you can see all buildings have been removed from the center, or at least the 5 closest buildings have been removed from the center of each of those vortexes. So I can call these the plazas or something like that. And then so there are the plazas. These are all of the buildings that we'll work with a little bit later. What else do we want to do? Okay, the park areas. Last thing we want to do with these, we have these park areas, we have these vacant lots. We're just going to join those together into like one big thing. I think actually I'm gonna, since these haven't been offset in the same way that all the sidewalks did over here, over here, I'm just going to copy this. Oops, what did I just do? And do it again just for the vacant lots. And then just grab those, and then I'm going to merge those together. So we have just one big kind of master list of all of the grassy spaces. And then just because they're sidewalks, we probably want a little radii on them. like that. So they look a little bit more like landscaped lots. Sometimes that doesn't work. You can see here, there's something weird happening. So one way, that it's like really sharp here and curved here. One way to get rid of that is to go to utility, curve utility, and reducing the least important vertices. So let's see. So that seemed to work. So you can, it's hard to tell because basically it's slightly shifting these things around, but sometimes there's like some, if I turn on there's just lots of like hidden hidden control points for these. So by doing this, you can see it's just grabbing the most significant of those corners and getting rid of all the least significant ones, so that when you fill it now, you get nice fillets on all of the corners rather than something like this where it's only filleting up to the next polyline point. All right. Getting caught in the weeds here a little bit with all these little details, but hopefully it's helpful for some of you. Okay, let's talk about human. So human is a lot of different things. I use it primarily for baking data out of Grasshopper and also for creating layers, which you can see they're already, I've used it already in this file due to opening up that other file. Again, I forgot to save this file. Okay. Okay, let me just hide a few more things here. Okay. All right, so that's starting to look pretty good. So yeah, human. I want to be able to use, or yeah, human I use in a variety of different ways. Number one, I use it for baking and for creating layers. Two, it has really good, being able to make hatches is really useful. Sometimes I use it to create like little mini like heads up displays to like render things to the Rhino window. Like if I wanted just like a heads up display, like in a video game where, you might see your life, how many lives you have left, or your health. Like you can do that inside of Grasshopper's window, or inside of, the Rhino viewport, by using render text to screen or render mesh to screen and things like that. And then sometimes use it to create custom line weight previews, just to be able to like very quickly pop something out on the screen. And it's just measured in pixels, not measured in like line weights like you would for printing. All right, let's talk about layer creation first. Because I had that other file created, I had already opened it. All of these layers have already been created, but I'm gonna there's nothing on any of these. I'm gonna delete them all. Like maybe create, what's a good one to create here? Oh, well, the curbs, yeah, or not the curb, but the grassy areas. Okay, so I know I want to bake these eventually into so that they can be filled with like some tone in Illustrator to make them look like grass. So first thing I'm going to do is create a sender that sends this, and I'm going to call it, what should I call it? Park outlines. All right. So then I'm just going to go over here, and I'm going to create a big scribble called outputs. Well, not that big. And then I'm going to get a receiver. and get those park outlines. And I want to create a layer for those park outlines. So I just want to be consistent with my layer system here. So I think they were called park outline, very similar to this. So I'm going to create first, I want to create that layer. So I'm going to grab the create modify layer component. And it's a really powerful component because it's basically creating a layer inside of your Rhino document with properties. So you can say the color of the layer, like what print, like if you're printing, like what the curves will, what line weight they'll print with, what color the lines are, what type of lines those are they dashed lines, and so on and so forth, or if there's a material assigned to the layer, which could be helpful for like rendering purposes and things like that. So it also allows you to create nested layer systems, but I'm going to show you just the simple version first. So I'm going to create a layer called park outlines, or I'm going to create, I should say, just a text panel with that. And if I plug that into the L input, notice immediately over here in Rhino that I now have a layer called park outlines. But I want it to be a little bit more sophisticated than that. So I want to be able to have nested layers. So notice at the bottom here, it says layer name only. If I right click and use full paths, it says layer full path. And if I now create something, I'm going to type 2 slashes, and then I'm going to type park, and then 2 colons, and then type outline. So in Rhino, if you use 2 colons, or in Grasshopper, I should say, it means that you're going to create that whatever is on the left side of the 2 colons will be the parent of whatever's on the right side of it in the layer palette. So if I plug this in, now look where I have a layer called park, all in capitals, and a sublayer called outline. It doesn't have to be all in capitals. I'm just doing that to demonstrate that that like the parent layers are capitalized and then the sublayers are not capitalized. And then you can use that information. So there's both the layer that's being output, which is the outline layer, but then there's the full path layer name over here. So it tells me, you know, I can now bake things to a specific sublayer. So let me now create the baking component. Well, first I should create the attribute component, and I'll get the baking component too, because they all kind of go together. So the baking component has 3 inputs. There's a Boolean for bake. So if it's true, it will be baked to the Rhino document, the geometry that you want to bake, and the attributes of that geometry. So things in Rhino, it's sometimes a little confusing, but like if I were to like make a curve here, that curve was made on the default layer. I can take that, if I, you know, it's shown black here because the layer is black, but I can also select this, go to properties, and say that the display color is red. And now it's red, even though it's on a black layer. So you have to be kind of careful about these things. Sometimes it's useful to have that, but in my case, I don't want to change any of these. I just want it to always default to whatever the layer has. So I'm not going to put anything in any of these except for the layer. And I also want it to use full path. So again, you want these to always match. So I want full path to go to layer. And that's the only attribute in this example that I want to use. And then that attribute will be applied to this geometry when I use a button. Rename that button to bake to always just remind me. And that by default, it's false if it's not clicked. And if I click it, it's true. So if I plug this in to a panel, you can see that it constantly says false if I don't do anything. And if I press it once, for a split second, you say it says true. And this is important because it's some people will use a Boolean toggle like this, and then they'll go like that and bake and then like turn it back to false. And that will work. Like you can see now there's data here and it did get baked for the whole document. But the problem is sometimes you have dynamic content, like maybe you have a slider somewhere else in your file and you accidentally forgot to set this. So let's say I've set it to true, so it's baking right now and it's baked once. But if I go somewhere else, let's say back to here, I don't know, let's change something radically so that if I go to here and it's updated everything, but it's now rebaked another set of curves to the exact same layer. And if I do this, and imagine this is like something in Kangaroo or it's animated, you're going to be baking like every split second and you're going to crash your computer because it'll run out of memory with baking thousands of lines every few seconds. So don't use a Boolean toggle for baking, always use a button instead, like this, because as soon as you press it, it automatically goes back to false. It goes true for a split second and then false. So I can just press it once and they're all here. All right. All right. So this, I'll put another scribble and call this the park outlines output. And this is just a convention, but I tend to always change all of my outputs to red or pink or something like that. Just kind of highlight that that's where you need to go to in the file to actually get some data into Rhino. All right. Where are we here? So it's noon, so we have 2 more hours left. That's not a lot of time. So I'm going to just jump into clusters. And the way I'm going to do that, I'm going to show it to you first. So this is a cluster. Hopefully it's working. It's not quite working. Because I don't have everything here. You can see some things are being created, but there's very, very few of them for some reason, only 5 of them. Now, why would that be happening? So there is a null in here. Sorry, it's a little tricky copying things from one file to another when you haven't fully checked everything. But that's kind of curious. So let's see what's going on here. Well, first of all, there's something not quite working. Where's this going to? Oh, yeah. Okay. So I don't know why it's not working, but I do see, so this is good though. It's always good to have things break because it will, I can show like debugging. So I always bring up, first thing I do is bring a panel out to like look at the actual data. And the first thing I notice here is that like at number 7 and 13, and there's probably a bunch all in here that have null values. I don't know why they're null. They may have like something somewhere. Oh, it's an invalid curve for some reason. Okay, so if I kind of go back upstream, let's see how common these things are. So here they were fine. And then here, when I reduced, you can see a few got introduced that are now invalid. So that's not great. It basically means like the curve has been so reduced that it's like only has one point in it or something like that, or it's now become a line rather than a like a closed curve or something. I don't know. Something has happened to turn that into an invalid. And I guess I wasn't using this previously. So the easiest fix would just be to like bypass it, or to find some other way to reduce it rather than using this component. I think I'm just going to bypass it because just to save time, I don't want to take too much time debugging something like that. So you can now see the tree function or the tree cluster here is working. But what is this thing? Like this doesn't look like all of the other components that are up here. It's like, first of all, it has lots and lots of inputs. Second of all, if I hold my cursor over it, it has this like microscopic view of another file. And clusters are really, really important. They're kind of like blocks in AutoCAD, where they're basically reusable data, reusable code. Whereas like blocks in AutoCAD are just like reusable like drawings, like a piece of furniture or something like that, that you might be putting like an office chair, you might put in a plan that you don't need it to be a different office chair every time, and it saves a lot of money. So they're not money, saves a lot of memory, I should have said. So clusters are very similar, except they are, you can have different inputs into them. So if I were to copy this to something, somewhere else, I could reuse this in a different way. I'm not actually going to reuse it in this file. But if you change it in one place, it changes everywhere. But the inputs can be different for each one of those instances. So how did I get this thing? So I'm going to open this thing up and kind of destroy it and recreate it so you can see. So I'm going to just copy everything that's in here. And then I'm going to discard it. And then I'm just going to zoom out for a second and paste in the center. So it's not going to work because there are no inputs right now, but I'm going to show you how to do all of this. I'm just going to delete all of these things. Well, yeah, I'm not going to do all of them because I also have to recreate them all. All right, so what is this thing doing? So this is basically just a normal Grasshopper file that I created and then I turned into a cluster. So I'm gonna just get it kind of semi-functional. Let me turn off this thing so you can see what's happening. So first thing that it's asking for is the tree border area curve. So those are all the parks, I believe. So I'm gonna get the get a receiver and find the park outlines and plug that in. All right, so things are kind of working. So if we step through this, I'm not going to explain all of these different things, but it's basically creating a block around each one of them, turning that into a rectangle. And then I want to create a bunch of points inside of that based on a certain density factor for the trees per square meter. So I don't remember what that was. Let me see if I can zoom out or over here. So I'm just going to select a few of these, bring them down so I can reuse those sliders and not have to recreate all of those numbers. So if I were to plug some of these things in, you can now see there are points, and then I start deleting the points that are not inside of those park boundaries. That's the wrong one. I forgot to copy something. Wrong one. So these are just some seeds. and so forth. I'm just going to get it to the point where you can kind of see what's happening is that there's now a bunch of points that are located inside of park areas in one way or the other. And to get kind of more detailed, there's a bunch of things in here that they're tending to make park or trees on the border of parks, but there's some random chance that it might not be on the border. So basically, like, how do you create, if I go back to this, that I wanted there to be trees that were kind of making clearings on the inside of some of the larger park areas. So there's basically a random chance or a higher chance or higher probability that trees will be created on the border of parks than they are on the center of parks. And I could have changed that to be the other, that there's like clusters of trees in the center of the park or something like that. There's endless different ways that you could populate these, but that's the way I chose to do it. All right, so again, I'm just gonna get this back to like being a functional Grasshopper file so you can see what's being created. These are just the radii of the maximum and minimum radii of the tree, and a seed for that. And then some heights. And then I need a shadow vector, which I've already created. So let me just get a receiver and get the sun vector and plug that in. And what should be created over here are like one set of canopies, like a slightly offset random canopy below that, a trunk in the middle of it, and then a shadow underneath each of one of those. So what I often have in files is that I want to be able to create like different clusters of trees. Like in this particular file, that's just like everything, no matter what park it is, it's all getting the same type of tree. But sometimes I want to be able to say, okay, here are like vacant lots that are like super overgrown and really dense trees, or here's like a dense forest on the outskirts of the city, or yeah, here's a park that has very few trees and a big clearing for a sports field or something like that. So it would be really hard to, or I mean, I could take this entire set of code and then just start like copying and pasting it everywhere in the file, and then just, you know, going and changing the heights and the densities and all of that for all of the different types of parks or park trees that I would want in one file. But a better way of doing that is to create a cluster. So a cluster is, like I said, it's a way to reuse kind of Grasshopper code without having to copy and paste that code around. So the way you create a cluster is by going to parameters, utilities, and cluster input, cluster output. So you grab a cluster input. Anything that you want going into that file needs to be labeled as an input. So the trick to doing this is you want the output to have nice names, you know, all of these to have nice names on them. So the way to get a nice name is to right click on the component that you're inputting and enter the name that you want there. So when I input this in, it automatically creates that name for you. So I'm going to do that a few times. I'm just going to pull these things out away from them. And then I've already renamed them just to save time here. So each of these already have, if I right click on this, it already says tree density factor. And I'm just going to do this a few more times. And the other thing I want to mention is that it's important, like you might notice, like, why did I pull this out or something down here? Actually, I don't know why I did this one, but the order of all of your, the order that these names show in is the order by which they are placed vertically on the canvas. So if this one were to go down here, this would be the first name, second name, third name. So if I do it like this, I can then kind of create some type of hierarchy or organization in the cluster. Okay, so I'm going to keep on doing this and move. As I do that, I'm going to move these other ones out. Just take a second. Just a couple more. Actually, just one more. Oh, already have them here. Shadow vector. Okay. Let's move all of these out. So there are some I was like, it just doesn't, the ratio of a trunk to its canopy is always going to be a constant. I mean, I guess if it's a different type of forest or a different type of tree species, it might have a different ratio, or it can be random, but I didn't really care. It's not going to be seen. The other thing that you need to do is do the exact same thing for the output by doing cluster output and connecting those to all the things that you want outside of the cluster that you want to be able to access. So any of these other things, I can't access it once I've made the cluster unless I go back into the cluster and edit it and add a new one of these outputs. All right, so now that all of that is done, I mean, it looks like it's not working, it's all orange and it's not really working. And it isn't because there's no inputs, but if I select that all and then right click and go to cluster, it clusters that all together and I can double click on it and it's all still there and I can edit it. But you have to remember that when you edit it, you're editing all instances of that cluster, which is both dangerous and helpful, right? Like if you realize you made a mistake, like for instance, let's say, I don't know, for some reason, I want, this, I don't know, I want this thing as well. I could plug this in. I don't even know what this is. I think it's like shadow. I don't know what it is. Shadow 2, I'll just call it. I plug that in. I right click, go to save and close. And now I have this new output called shadow 2. So I don't want that. So I'm gonna go back in and delete that. Oops. Delete that. Go up to the little box in the corner, save and close, and now it's gone again. So now I can go back to here. I'm going to put some outputs on it so we can actually see what's happening as this gets so park outlines, tree density factor, density seed, gradient seed, canopy min, canopy max, radius. You can start to see them appearing. Now the shadows will start to appear once I add in the vector. Like that. So now I could, if I wanted to, I could use like a different, let's say I wanted, oops. For whatever reason down here, I wanted to create another park. I could select all of these things. I'm going to move them down here, but then use this as the input. And now I could, change lots of things around, make them, much bigger trees or something, and much taller trees, or make the density much lower or whatever I wanted to, without affecting all of the other trees that I made up there, while still using the exact same code. So it's a really, I use clusters quite a bit in my work when I realize that I'm like doing something over and over and over again in different files. It's a really great way, like especially if you're working on different projects. You do something in one project and then like a few months go by and you're like, oh, I totally want to use that code from that project I did a couple of months ago. That being able to have it as a cluster is really great because you can just save a cluster in a file somewhere that you can always just access and update the parameters for it and make it do something new. Lastly, on clusters, I'm not going to go into detail because again, I think it's a little buggy still. It's in beta, but McNeel, who makes Rhino and Grasshopper, has created a super powered version of clusters called hops. So I have hops installed here, and it doesn't look like much, and it isn't much. But let's say I'm going to just do like a super dumb example. Okay, so I'm going to open up another file, and I want to take this some shape, doesn't matter what it is. Okay, I want to take this shape and I don't know, I just want to do something really simple and fast because we're going to run out of time. So I'm going to let's say, I don't know, scale it somehow. That's really fast. I'm going to take that shape and I want to scale it around its own center point. Like that. Okay, really, really dumb, simple file. So I can turn this into a cluster that not only is like an external file that you could reference or someone in your office could reference, but even somewhere else in the world could reference. Like you can load these Grasshopper hops files onto a server, and then anyone anywhere in the world could access those and basically treat them as if they were clusters on their own in their own document. So the way to do this, so this file at the moment, it's doing nothing interesting, right? Like it's just taking a curve and scaling it by 50%, but let's make that into a parameter. So I'm going to take this and okay, so this is the whole file. Okay, not fancy at all, but I want to turn this into a hops file. All right. If you have hops installed, you should also see all of these purple components here. So I'm going to get a couple of them out, get geometry and get number. And I'm going to plug this into here and this into here. So obviously our script isn't working anymore because these things are empty. And I'm also going to delete this guy and I'm going to delete this thing. And then I always forget this step, but I think I want to create just it's going to be kind of weird, but I think I just need to create like a little group and name it, I'm going to forget, RH out. And I think it's like you can do anything you want. You can just name your output scaled polygon. Pretty sure this is how to do it. I'm going to save this. I don't have to select it all. I'm just going to save this to this. It doesn't matter where it is, just so I know where it is. I'm going to call it scaled polyline. And again, doesn't matter what it's called. Okay, so now I'm going to go back to my original file here. And I'm going to right click on this and go to path and then find where I have that hops file. And this is where it gets a little buggy, and it sometimes takes a few seconds. Even with small files, it takes a few seconds to like, like I can't scroll in or out or anything right now. It should be super fast, and I don't know why it does take time sometimes. Or maybe it's crashed. There it goes. See, it took like 10 seconds for a file that shouldn't take that long. But notice it has the name of the output, and I could have renamed these to something else, and I still could go back and redo it. But I'm going to show you now that I can then take that shape that I had before, and then, some other scale factor, and it creates that. So it's basically opening up in memory another Grasshopper file and running that. And because of that, it opens up, if you have lots of these in different parts of your uh, main document here, it's running each one of those on a separate processor or separate thread, and it runs relatively quickly. I've tried to get it to work with like something as complex as this tree, and I can't get it to work. It just like breaks and has lots of like bugs and things like that. You can see how long it took to start. But I think it will be better in the near future, and I think it'll be kind of in some ways, like the future of Grasshopper, in that like components that you make, like you could publish as, hops files that are available for anyone to not download, but to use. Like they couldn't, you could just be running a Grasshopper file off of some server that I'm sure at some point McNeel will create. And that essentially I could imagine like even payment systems and micropayments and things like that, where like computational designers could subscribe to a service and get access to certain like plugin like features, but without having to download and pay for a plugin that way. Like you would only maybe pay for it every time you use it or something like that. All right. Maybe we should stop for another maybe 10 minutes this time, and then we'll spend the rest of the time. I'll open up that final file, which I think I still have open right here. And I'll go through the baking process for this, and then bringing it into Illustrator, creating the wallets, and minting and all of that. All right, so 10 minutes from now. I'll see you all soon. All right. Sorry, that was a little bit over 10 minutes. Okay, so I answered a few of the questions during the break. Sorry, I didn't have the Q&A open while I was talking, so I didn't see some of the ones when people were like asking me to zoom in on something, but you have the files, so hopefully you can find what you're missing. All right, so Illustrator and the blockchain. So there's the last two things we need to do. And we have about an hour and a half, I think. So I'm gonna, I think I've already, like with these settings, I think I already minted this. So let me just go and find that. All right, so this is, like I was saying, Taya is very recent, as of like 5 days ago or something. The new name for the community kind of based, community led, I don't know what you want to call it, reincarnation of what was called Hic et Nunc. Very hard as far as like naming something that doesn't flow off the tongue very well. But maybe go to this really quickly. Okay, so just to give a very, very brief history of the last year of NFTs, probably many of you first heard of NFTs in the last year. They kind of started, a lot of people heard about them when Beeple's, whatever it was called, 5,000 days project sold for 69 million, like last February or something like that. They've been around for a while, not too long though, like in the 5 to 10 year range, less than 10 years, definitely. And in various forms on various different blockchains. In the last year, one of the things that started to happen was there were a few different markets that were primarily on one blockchain called Ethereum. And as people got more, as NFTs became more popular in the last, or like 2020, fall of 2020, and then in winter of 2021, there was a lot more usage on Ethereum, and fees started to go up for doing anything. I'm not going to get into like exactly what a blockchain is and why would there be fees and things like that. But kind of what you need to know is that like every transaction has a fee that's associated with it, because somewhere in the world there's a computer that's running that transaction, and you're essentially paying for that time in a way. And also to have it, like the security of it, have that transaction validated and checked and so on against the blockchain. So what started to happen is that like artists were trying to mint things on Ethereum, but the fees were very high. And it's like, if you're trying to sell something for $100, but it costs $100 to even put it on the market, it doesn't make much sense. So there was a very rapid inflation that happened, I would say, on that market, because the fees were so high. The prices had to also be very high. And it made it very inaccessible for a lot of like young emerging artists to kind of get too involved in it, because it was kind of risky. Like I myself, I'm not very young, but I tried to mint something on Ethereum, and somehow it got corrupted. Like the JPEG got corrupted as it was being minted, and so I ended up with like a black JPEG, and it cost me $70. And there's various ways around that, and it was my first time doing it. I'm sure I would have learned how to do it better, but it just like kind of put me off a little bit, where I was just like, I wanted something that was like less, I didn't mention this. So also a lot of the marketplaces on Ethereum were very curated, which meant that like if you're an artist, unless someone selects you, like you couldn't like adds you to the membership, like you couldn't mint anything, like you were just locked out of it. And I just didn't like that either. So between the fees and the problems I was having and things like that, I decided to look more at other alternative blockchains, and specifically blockchains that were more energy efficient. So there's a difference. Again, I'm not going to go into blockchains too much, but there's a difference between proof of work blockchains and proof of stake blockchains. And proof of work are things like Ethereum and Bitcoin and things like that, that the work is literally referring to the work that the computer has to do, that has to solve, complex equations to verify that something is correct and things like that before it will allow a certain transaction. And that work, that all of that work costs a lot of money, and it also uses a lot of electricity. And Ethereum is trying very hard to get off of that system, because as you've probably heard, like it's hard, like there's a lot of energy inefficiency, a lot of wasted energy going to just powering the Ethereum network. But also it's just expensive, to keep on having to buy GPUs and other things, that will do all of that, and it makes all of the fees higher. So other networks, other blockchains like Tezos have been around for a while, but started to get much more popular last winter because they don't rely on all of that extra kind of computing power and energy use to verify the system. And so I'm not going to go into how they do it, but they do it in a way that's called proof of stake, where you kind of everyone kind of puts up a certain amount of their funds in a way, and you can take them out at any point, but you think of it as almost like a deposit, that the network has like a deposit, and that you lose that money if you try doing something like sneaky and try to like game the system, and somehow you basically that those deposits, those stakes get pulled, and it doesn't, basically that's how they secure it. There's kind of like a collective trust, let's say, that, or trustless trust, that gets created that way. Anyway, so Hen was started in last winter. Also, it's known as HEN, but because the name of it's almost unpronounceable. And it was started by a Portuguese guy, Rafael Lima. And it was, he's really interesting. He's like a philosopher, like PhD student, I think. And like he had a lot of interesting ideas about decentralization and open source, and of kind of this, punk kind of mentality of like, screw all of these big corporate NFT platforms that are taking a lot of money. We're going to not have any prices easily seen. We're not going to have any analytics that are about like who's the most popular artist. We're not going to even show you the artist's name. We're just going to show you art, and you buy art you like. That was like kind of the concept behind it. It was really interesting, and a lot of artists who were just interested in the art started minting on it, and very quickly, way before there were like collectors, it was just artists collecting each other's work, and it has still, I think, the highest rate of artists buying work on the platform. And the way to differentiate between that, there are people who mint work, basically adding work to the network or to the market, and you can, so those are artists. And then there are people who are buying art from the network, and we normally refer to them as collectors, right, in the normal world. In the NFT world and in the normal world, you can be an artist who's also a collector. But many platforms have people who are just collectors. They're not like, they're just buying art. They're not making any art. And Hen was, I think, unique in that it had the highest percentage of artists who are also collectors. And part of the reason they could do that is that because the fees were so low and the artwork was priced very reasonably, often like $3 or $4 for a piece of work, but if you sell, 300 of them, you make some larger amount of money. So Anyway, it got started. It was super buggy, super chaotic, didn't have many features, but like the lack of features was a feature in a way that was very intentional. Like he didn't want you to know what was selling. He didn't want you to know like who were the popular artists and things like that. So it wasn't about investment. It was just purely about kind of the art. But very quickly, because it was an open source project, people started copying that software. So Object was the first one, object.com, and they even copied their name, OBJKT, refers to the token that, or the smart contract that was used to create the artwork on Hen, that it was called, each of the artworks are known as objects. So they object.com reused the name, reused a lot of the code, started rewriting the code, adding more features, and you can see just visually from the website, like hot collections, ending soon. Like it was all about like auctions that are ending soon and like trying to ramp prices up and highlighting who was buying the most and who was selling the most and things like that. And that really annoyed Rafael Lima, and to the point where in November of this year, he pulled the plug for the whole thing. But because it was open source, even though the main website was down, the really interesting thing about the blockchain is that the information isn't being stored, kind of like certain information is being stored on the blockchain, but the actual files and things like that are stored elsewhere. So even though the website was down, basically the website was like dozens of times recreated within a number of days. And all of your data, all of your files, your money, everything was still exactly as it was. And the community decided to kind of take over, and some community members, and say, okay, we're going to do this the right way. We're going to have like, boards of people who get to make decisions. We're going to turn this into a DAO, where if you've minted anything, collected anything, you get a say in how the website, the platform gets developed. And one of those was just the renaming of it. So you can see the two websites look identical, except for the logo. And the logo, every time you reload, it's a different logo because they're trying out different logos this week. Anyway, there are two other platforms I just want to mention. We'll be minting on Taya, but the two others are Versum. So two of the programmers who started or worked on the original Hen and got fed up with Rafael Lima's kind of chaos and everything that he was doing, left in summer 2021, and for the last 6 months have been developing their own platform, and it was released 2 weeks ago, and it's absolutely amazing. Like you can see just visually, as designers and architects, you can just see the graphic design, like that it's similarly focused on the art as Hen, and it hides a lot of the collector stuff. It's almost more, yeah. So anyway, you'll see, but it adds some features though, like auctions, Dutch auctions, English auctions, offers, things like that. Follow pages, kind of like Pinterest, and so forth. The other one that's kind of completely outside of all of this started in November, like literally a day after Hen was shut down. Totally unrelated to that though was FX Hash, which is more like art blocks on Ethereum, where instead of uploading drawings or images or things like that, artists upload code. The code then, when a collector buys a piece of work, the code runs once and generates a specific and unique NFT to that one collector. And then that collector can go on and sell their minted version. But it's a very different, but I think I wanted to bring it up because the way I've been talking about how to set these things up in Grasshopper, I think thinking of it as like a stepping stone to programming, that a lot of artists and architects are starting to think about how to take their art or their designs and turn them into code that could run on the blockchain. And like, for instance, you could design a house where there could be an infinite number of variations of the house. And then when you choose to buy it, it mints that one version for you. maybe no one else has that. So there was a question, can you also share the GH script of the long wall building? No, I'm sorry, I can't. That was number one, it's like, I don't know, what, 4 years old now. And it's also, mine. So I'm only sharing the code for this one iteration. And it's up to you to create your own. So, all right, so let me go back into here. So, or sorry, not quite yet. Oh man, there we go. So last night I minted this, the piece that you were seeing in Rhino, that has all those exact same settings. And you might notice with any Web3 application that things run a little slower. It kind of feels like dial-up connection because the data it's all very decentralized. It's not being stored in the same way and as like the normal Web 2.0 files are. So eventually things will change, but for now things are a little slow. So anyway, you can see here, looks like, I don't know, 2 people bought. I only minted 3 of them and they're 5 TES each, which is, I don't know, it's around $4, $4 US to 1 TES. So around $20. It looks like I did it last night. It looks like 2 people, and I still have 1 copy or 1 edition for sale. And what's interesting, you can see like all the operations like that. When I minted it, I said that I wanted 15% royalties. So if these 2 people who bought it, if one of them sells it in the end for some amount, no matter what it is, if they sell it for less than what they bought it for, if they sell it for more, hopefully, than what they bought it for, I always get 15% of that amount. And you can see who bought it and when. And I just want to mention a few things here because it took me like a few weeks to get my head around this. Number one, sometimes things are wallets can be anonymous, but they're always public. And that's a weird concept. That you think if something isn't public, it's not anonymous anymore. But you can have an anonymous wallet. So you can see, for instance, this wallet here. If I click on this, I can see what they've collected. I have no idea who this person is. Looks like they're have, I don't know, good taste. Oh, collected a few of my things. But they've also collected this guy, Zancan, is a French artist who just does absolutely amazing work. And other things like this artist, Helio Santos. You can see much higher prices, still not very high compared to Ethereum. So this, 4 times 17, 18, still not very high. But they sell out often within a day, some of these artists, and they make most of their money through secondary sales. Anyway, so I can see everything that this person has purchased. Not only can I see what they've purchased, if I scroll back up to the top and click on their wallet address, it brings me to a blockchain explorer, which shows me that they only have 0.7 TES in their wallet right now, which is about $2.88. But it also shows me every single transaction they've done. It looks like maybe they started only a couple weeks ago. But like, it's all, I don't know who they are, but I can see everything that they've done. I can see where they send money, who they've received money from, if they're delegating their funds, which means, well, I won't get into delegation, but it's basically, think of it as interest, that you can basically give some rights to your account over, and in exchange for that, you get interest back, usually about 5%. So anyway, you can see it's very strange in a way, in that it's like looking at someone's bank account. And because of that, everything, it's like what's called trustless, and that you don't have to trust it because everything is like public and you can trace everything. So there's often a lot of talk of like blockchains being used for money laundering and things like that. And sometimes they definitely are, but it's also very easy to catch people doing that because you can track, like you can track how they're sending money from one wallet to another and then eventually trying to take it out and put into a bank or something. So a lot of kind of bad behavior on blockchains is like very easily kind of detected and tracked, because at some point that money has to be brought out, and it's hard to take money out of the system without actually having like a bank account that's tied to an identity. Anyway, so I don't know where I was here. I already created that one. So I'm going to go back to this one, and because I'm going to be changing a bunch of things here, I'm going to middle click and turn off the solver. And then just, I don't know, I'm going to change a bunch of, to keep those, oops. That's probably enough, but I'm going to change a few more down here. All right. So now it's going to take, again, probably 30 seconds to recalculate everything. Hopefully it does and doesn't crash. But whatever this version is, as long as it's not like completely messed up, so you can see it's starting to come in, but still hasn't solved anything. As long as it's not totally messed up, I'll mint this one. So while that's doing that, maybe, well, let's see. Usually it just takes 30 seconds, so I'll just wait it out and maybe answer some questions. When adding the performers in Plaza centers, do you know why the receiver Plaza people points is failing to the data? It's the one group I can't get to work. I don't know, unless maybe it's not connected to anything. Like, are you sure it's connected to a sender? And it says, could you run an animation sequence to generate a bunch in a row? Yes, you definitely could. You know, especially it'll be a little complex to create the right amount of delay but yeah, you could create, you know, especially programmatically, using some other, you know, scripted features. You could, you know, change a bunch of things. You could have just one seed change all of the values as well. So that's basically the way the FX hash works. So if I just go back to that really quickly, it's a good thing to show you because there are a number of people doing interesting things on FX hash. So this is FX hash, and I'm going to go to my collection because that'll help me find some work. So for instance, Alex Grasser, who I believe is a professor of architecture, I think in Austria, maybe. I'm forgetting where he is, but it looks like it's still loading for some reason here. But he created this open plan project, and it usually does not take this long to load. Usually just takes a couple of seconds. Let me go. All right, maybe try someone else's. Oh, looks like something is wrong with the internet right now if all of these are happening, or something is wrong with the website. Anyway, there are a number of people doing kind of architectural work on this, but it doesn't look like let's see if I can get this guy in Convergent. looks like everything is down right now, unfortunately, on here. But basically, there's each wallet is used. So when you mint something, there's a random hash, like a random code that's generated off of your wallet. And it then uses that code as like a master seed for all of the other seeds that then generates the different variations. All right, so let me go back. This is probably done by now. Yeah. So I don't have it set up that way, but I could have all of these seeds be fed from another master seed. So I could just change one thing and everything would update. Okay, so this is all set up. I'm going to just delete all of these other layers, just to make sure that nothing is in the file. And I don't think anything is, no. All right, so I'm just gonna go through and start baking things and building up, and maybe I'll do it like this so you can start to see the geometry being built up. And I could also have one button that controls all of these too, but I don't. Buildings. That's weird. I think I messed something up here. Let me just delete these. Like none of the nested layers are showing up. I think I deleted them all before and I need to recreate them. So the best way to recreate them, I'm just going to select all of these. Let's see, I think this will work. If I disable them and then enable them, there we go. Okay, so all the layers are now created. So now they should be created on the proper layer, nested layer. This will take the longest for the people and then the people shadows. There we go. So I'm gonna just hide that. So now you can see, it's all there. It's pretty sketchy in areas, but that's fine. This is a huge file. So we're not going to be able to zoom in that far on it. So I'm going to select it all, export selected, and save it as an Illustrator file, and I'll call it CD03, 500 meter. Okay, so this is important. So right now this is full scale, right? So it's 500 meters by 500 meters. So I want to make sure that I change the scale so that 1 meter is equal to 1 millimeter. And I want to also make sure hatches, I don't think I have any hatches in this file, but sometimes I do. Hatches will import as solid fills, which is really helpful sometimes if you have a hatch. But I've exploded all of my hatches using human, and or created the hatches and then exploded them. And then in order layers just keeps them in the same order that you see them here. So this will take a few seconds. While that's happening, there was a question, would that, if you ran a sequence, you could, yeah. So everything I just did there, there are other tools that you can use. For example, sorry, it's hidden behind Zoom's screen share. Let me try to find it. Wombat I use to do like more advanced baking, where you can write any type of file out. So you could bake the geometry and then write the geometry to an AI file, all within Grasshopper. So that's like another level of, more advanced, but that's definitely possible. And I'm using that right now actually for a project that I'm doing where there are 600 different facade or 600 different glass panels for a facade that all have different frit on them. And each glass panel needs to have an AI file that would be sent to the digital printer for printing the frit, but also they need a DWG file for sizing of things to keep them for some reason. So there's basically 1,200 different files that need to be managed, and they all need to be automatically created with the right file name and all of that. So obviously you don't want to do that manually. So I used some tools up here for like checking like file names, exporting file to path, things like that. All right. Oh, why did I decide to delete the layers before export? It was more of a well, number one, I didn't have all the layers, I don't think, that I wanted. But I just, because I was like drawing random things in the viewport, I just want to make sure that I didn't have anything that I didn't want, anything that was I had hand drawn in the file. I wanted to make sure it was all just generated from the Grasshopper file. But yeah, I forgot that if you delete the layers, they won't be recreated unless you basically refresh that component or you change something. Like if I change the name of the layer, it would recreate the layer. But yeah, that's all. Okay, so there's a question about my hardware spec. I don't know off the top of my head, but it's a beefy gaming computer with a very good GPU and I think 64 megs of RAM and like a whatever the was it 3090 whatever GPU. I can't remember all the things, but it's like a Alienware thing. But I had to buy it through Alienware, unfortunately, but I would have tried to make my own otherwise. Anyway, this was the file in Illustrator that I had minted last night. So now I want to open up the other one. This will take a moment to open. And there are a few things I have to do. So Illustrator always opens with like a random artboard. So I just want to turn that into millimeters. And before I change the size of the artboard, I think I know how big it should be, but so it's like 600 by 600 roughly is the size of all the geometry. So I'm going to make my artboard like 650 by 650. And then, oops. Once I create that artboard, I can now select all the geometry, wait for a second for it to come up, and then I'll type in half of 650, so 325 by 325. It takes a second for it to move all that geometry around. While that's happening, did you upload in video as well? Did you upload a video as well? Do you mean for like wrong one? If I go back to, sorry, that stupid Zoom thing just gets in the way at the top. I know you guys can't see it, but I can't see any of my menus. Okay, so yes, some of these, if I go down further, like I've uploaded animations and GIFs. I've uploaded Hen or Taya now allows you also to upload code. So for instance, this is my first JavaScript that I've ever created, basically, or actually some of these other colored ones are JavaScript, but this one you can actually, I think, once it loads, hopefully you can see. So this isn't an image, it's actually like code running on the web. And you can see that by I can click and add more more circles to this, and it will, yeah. So basically, you can do video, JPEG, GIF, PNG, JavaScript, MPEG. I don't know. I don't know what the whole list is. We'll see when we go through the minting process, though. All right, so it's all here. It's roughly centered. It doesn't look great to me because I think it's centered based on the bounding box. So I might just, I don't know. Well, it's fine. We'll leave it like that. All right, so first thing I like to do now that it's all here, I'm just going to hide everything and then start moving things around. So actually the diagram layer, these field lines, actually I do want on top. I'm just gonna pull up, so you can see if I can get these on the same page at the same time. Why don't I see it? There it is. Just to help refresh my memory of the different settings, and I'll try to do it as quickly as I can. Oops. Okay, that should work. All right, so the field lines, I'm doing, select them, and they have 0.25 and the stroke. I know this isn't the most interesting thing in the world, so I'm gonna go really quickly through all of this. So that layer is done, and this is the layer of the order layer. So then I lock that layer just so I make sure that I'm not like doing anything. Oh wait, what's the next layer? Roof skylight. So then I drag that up into the proper order. Select it. I think it has a very thin line weight and it gets white, which we won't be able to see yet. Lock it, and then roof shadow. So it's basically just all about finding like it's like it's not a real digital model. It's not a like perfect drawing. You're just like hiding things behind other things to make it look more realistic. So for roof, the shadow, I mean, it's a black, has no stroke. So black color, no stroke, and it is 30% transparent. Building outline. I wish I had a script for all of this. I should do that. And actually, I haven't tested out enough. Building outline, not bush outline. What I was saying in Rhino there, that you can set the print weight and color and things like that. Not all of that stuff always gets translated through to Illustrator, unfortunately, but I haven't actually fully like tested all of those things out. And there would be a way to like actually export things with all of the proper line weights and at the right scale and all of that. And I wouldn't have to go through all of this manual stuff in Illustrator, but it's much more advanced and I don't know it well enough right now. All right, so building outline. So that's not going to have any fill and it's going to have a heavier stroke, I believe. Let me go back to the Acrobat. No fill. Yep. All right, lock it, and then building hatch. Select all, and that has no fill, a very light stroke that is at 50% black. All right, lock it, and then building fill. And that has no stroke and it has 7.5% black. So we're starting to, you can see it building up slowly, but surely. Bush, wait, tree canopy. Let's keep on doing that. Both tree canopies. They both have very thin line weight and black. Well, actually, they're different from each other. So let me just lock one of them. So the top one is 2.5% and the bottom is 20%. And then both of them get I might not be able to do that. Let me do it one at a time. %, just the fill gets 50% transparent while the stroke stays at 100% transparent or opaque. And trunk. Actually, I think trunk has no stroke. And bush. Sorry, this isn't the most interesting part of the day. Nope. Okay, people. And okay, so now you can see a lot more people on the screen. And then we have a bunch of shadows all in a row. So let me just actually, I'll just do them one at a time just in case. Wait a minute, what just happened? I don't think the building shadows got exported for some reason. Or at least not many of them. Let me just see what this looks like. Oh, there they are. They are there. Oh. No, they're not working properly. I think I didn't update a vector or something because they're all, it looks like the sun is at noon, like like it's perfectly down. Okay, so this is a good example. Things like this happen. So why didn't the building shadow get generated properly? Where is the building shadow? Should be right here. And let's see. Or first of all, just let me double check. Turn everything off. And then yeah. Okay, so just verifying like the shadows definitely didn't work properly. So now it's just a matter of like, why didn't they work properly? And let's try to figure that out. So turn that off again. Oh, those are roof shadows, building shadows. Ah, yep. So somehow I missed that there's no vector going into this. It must have, I didn't select it somehow. So let's get a remote receiver, enter in the sun vector. I'm going to go back over to the building shadow and just delete everything. And then I think it should be working. Yes, that looks a lot better. And then go back to building output, building shadow, bake that. Now it's all there. It's gonna be a little tricky. Maybe I'll like do one little thing to help me here. I'm going to like take this line and copy it onto the building shadow. So I have some form of reference so I know where to export or where to import that in. Oop. All the same settings. So if I go back now to this, I'm going to select everything that's on this layer. Make sure no other layers are turned on, delete them. This almost happens every single time I do this, that I forget to, something doesn't work and I have to go back. And it's good that it does in a way because the way I've set up with all the individual baking and all of that, it makes it work pretty well. All right, so I'm going to zoom in. I thought it was that one. Maybe it's this one. All right. Back. All right. So with really complex things like this, it's always good to, if when I fill this, just to make sure if there, sometimes there's like holes inside of them or something like that. So in Illustrator, it's always good to go to compound mask and make, and then go to window attributes and make sure use non-zero winding fill rule. So that way, you know, things like you'll find like little openings in the middle will appear then. Let's turn everything else back on so you can see how this is starting to look. And then let me just get the last three. Oh, actually, and while someone asked if there were any 3D files. Yeah, you can do whatever it's called. I don't remember. GL, whatever. I can't remember the format, but there is a 3D format you can mint. All right. Park outline. 15. And curb. And then the last one, crosswalks. Um, all right, so that's done. So let me save this. And then you can decide what resolution you want. You can also, you can mint SVG files. They just have to be embedded in a, like a, actually, I think you can just do SVG files on Hen or Taya now, just natively. But yeah, there are templates for a lot of these types of things too. All right, so I want to use artboard. I want it as a JPEG export, and then I want it to be grayscale, so it's smaller memory. Since everything is already just gray anyway, 300 DPI. And that should now be here. Yeah. All right. So we have our image. So next thing to do is to create a wallet. All right. So I'm going to do this just because I already have my wallet, like my personal wallet created. I want to create a new one. So I'm just going to open up 2 different browsers. So on the right is Brave, on the left is, or sorry, on the left is Brave, on the right is Chrome. Let me go down here. Okay, so like I said, we're going to use Temple. So we need to, like when I'm in Taya here, you can see that I'm logged in. Well, that's not even the right concept. Logging into something is like, it's a very Web 2.0 concept, like logging into Instagram or Facebook or Twitter or something like that. It works very differently with Web 3 applications in that your login is essentially your wallet. So you have to sync your wallet, your digital wallet, to a website. And then that website can kind of read elements of your wallet and populate the website specifically for you. So you can see here, this is my wallet address. And because of that, when I go, I can manage my assets, but those assets aren't owned by Taya. They're just simply on the blockchain. So I can also manage these assets. Like I could go to other websites. I could go back to the original Hikanunk, which is really weird because he, like I said, that guy Rafael Lima took it all down in November, but like as soon as the name was changed to Taya by the community that kind of took it over, he put his website back up again. So you can see I'm not synced here, but I could click on this, sync to Temple, and then connect. so far now it shows that I'm connected. So now I can go and manage my assets in the exact same and the same exact assets. So this is really, really important that the assets that live here, the artwork that I've minted here is exactly the same as the artwork on Taya. If I go to manage assets here, that the artwork isn't owned by the website. And that's like, it's just a really important concept to kind of, because it's like confusing, like compared to like uploading something to like Flickr or I don't know, Pinterest or whatever, like you are uploading your content to their servers. This doesn't work that way. And the content is like still yours and you could do whatever you want with it on any of these platforms. And they're just like reading the blockchain basically and visualizing it for you and allowing you certain operations like collecting, buying something or selling something, or now collaborating with other people. Okay, but you can see I don't have that temple extension up here that I can use. So if I went to Taya.art, you can see it says sync. And if I try to sync, it says temple wallet not installed. And there's some other wallets, like I've also used Kukai, which works really well. It's kind of a weird one, but if you're having some problems with like creating a wallet, it might be a good way to start. Kukai is based off of it's kind of like a weird mashup of Web3 and Web2, in that it uses your Twitter handle as your wallet, which is security wise, I don't know, but I have one for just like quick mobile, like if I'm on my phone and I want to buy something, Kukai works really well for that, whereas Temple doesn't work. It has to be on a computer, not on a mobile phone. Anyway, but it's not installed, so I can't like sync my blockchain information with their account. So I need to install it. So I'm going to go to search Temple Wallet. And then whatever, I'm on Brave in this particular browser, so I need to install it for Brave. So if I go to add, click extension. Now you can see it's up at the top of the browser. And if I click on the extension little puzzle piece there, I can pin it back to the browser so it shows up here. So at the moment you have two options, because I haven't like connected a wallet yet with the extension. So I can either import an existing wallet, excuse me, so I can, for instance, my main wallet, I could import it in here if I wanted to, or I could create a new wallet. So I'm going to create a new wallet because that's probably what you're going to be doing. So I am going to create a password, and I am going to use a password manager. To do this. So I'm not going to show you what my password is and a few other things, but I mean, this is a throwaway account I'm making, or wallet right now. So I'm not too worried about it. I'll delete it later, but I'm just going to generate a really long password. Over here, and I'm going to put it in and see if it satisfies all of the different things of numbers and letters, uppercase, lowercase, and it does. And then I'll accept the terms. Okay, so this is important. This is actually the most important thing. Your seed phrase, I'm not going to click it here, but actually, well, like I said, I'm only going to add like a few pennies to this account, and then I'm going to delete the account. So if you guys see it, it's fine. So your seed phrase is essentially, think of it as like there are two different types of passwords for wallets. And there's like a general password to log into the wallet. And then there's another password that you can use to install that wallet on another computer. And once you install that wallet on another computer, you can do anything you want with it. So you never ever want to share the seed phrase with anyone. And so actually maybe even with the, I'm going to be super secure. I'm just going to move this off the screen and then click on this and copy it. So you won't be able to see it. But I'm creating a new, there's lots of, how should I say this? I'm not super knowledgeable about all of the different ways to keep these things secure. A lot of people believe that you should keep it only, what's the word? Like on a hardware wallet, that you should keep, or you should keep all of your seed phrases on a piece of paper locked in a safety deposit box and things like that, which is probably true. I'm not going to do that for this example. All right, I just need to do a couple more things here. To verify it. Okay. All right, so I've set up my seed phrase, I've saved it, encrypted it, and so forth. So now I'm going to confirm. It says your address and balance. So welcome to onboarding. So I've created the account, and this is just an example. It's just an image. It's not showing you a balance. It's not showing your actual wallet address. Think of it, a wallet address as a user ID. Like it's a public thing, just like an email address is kind of like a public thing. So don't worry about like your wallet address being shared. It's your wallet password and your wallet seed phrase that you don't want to share. So anyway, your wallet address will always be shown looks something like this. It's kind of this crazy long alphanumeric string, and then under that will show your balance. You can then, either receive funds, or you can buy funds, swap, so forth, send funds to someone else's wallet, and so forth. Let me just make this full screen. There we go. Next, it also shows you what collectibles, what NFTs you have in your wallet. Sometimes people will send you an NFT like for free, like you can swap things with people, or sometimes people just give you a gift. And you can have multiple different wallets within your account too, which is kind of weird, but think of them as like different sections within your wallet. All right, so this is my wallet. I can name it whatever I want, so I'll call it Matsis Test. You can see I have 0 TES in the account, and then it will show you usually whatever the currency is of where you are. So obviously I have 0 TES, so I have 0 US dollars. And it also shows you a bunch of other Tezos-based tokens. Tezos is obviously the main one, but there's like wrapped Bitcoin and other things like that that you can deal with. The big problem, of course, is I can't use this account yet to do really anything, because I don't have any funds in it. And to do anything on any blockchain, you need funds. You don't need that many on this blockchain, but you need some. Now I'm going to do something you might seem weird, but over on this page here, I'm logged into my other account. with Tezos. And like I said, everything is public. So I'm not like showing, like, you're going to think I'm like, oh my God, I'm showing you my bank account, which I kind of am, but it's, you could have seen it anyway. So what I mean by that is you can see I have 1400 Tez, which all of that I've collected from just people buying work in the last few months. So, and you can see that by, if I click on this, my address, and I go to a blockchain explorer, I can, well, I already did it. I can, and any of you could do this. You could search for me, you could search for my address. All that is public information. And you can see how much money I have, where I got it from. If I click on these, you can see who I got it from, like who was buying the work, which work I bought. So it's like, it's very much like a credit card balance or something like, or a credit card statement, I should say. And it goes back to last March when I first started, and I can export things from this, like my tax information and all of that. So I know how much I owe. And I can look at any one of these transactions and yeah, get more information about it. So there are certain things that come in. Let me see if I can find one. So like this, for instance, where it says stake now payments. So every, I don't know, 2 or 3 days, I get sent like another few dollars, like $2, because I have staked my account with this company called Stake Now, or not a company, but I guess it is a company. But think of it almost like that they're a, it's not quite like a bank. It's more that like, and I'm very confused about this myself, but essentially every transaction has to be like verified. And there are nodes that, like computers that are running, that are verifying that. And they're called these delegators. And these delegators are, spending money and time, power, and so forth, verifying all the transactions on the blockchain. And they can verify more things if you delegate some of your funds to them. And in exchange, because they're being paid to delegate everything through the processing fees that happen. So think of it as like one giant, super distributed credit card company that all of these individual distributor or delegators are getting processing fees for verifying the transactions. So when you buy something, a small fee is going to them, and you can get part of that fee back by adding your processing power in a way, like your funds, which it's very weird to think of money as also processing power, but that's kind of how it works, to them. And in addition to that, you're also giving them your voting rights. So when things come up in the blockchain of like, should we upgrade with this or should we upgrade to that? It's a distributed system where basically the more funds you have, the more like vote share you have. And so these delegators, because they're funneling all of these, they're getting the delegation of funds from thousands and thousands of people, they get a bigger vote share. So to kind of thank you, or to not thank, that's the wrong word, in exchange for you handing over your voting power, which my vote is almost meaningless by itself. But when I aggregate it with other people, with delegators that I trust, that, and you can basically switch delegators at any moment. And it's pretty much immediate. So if I see that a delegator has voted a way that I don't like, I can withdraw my delegation from them and put it with someone I do like. Anyway, so every few days I get a, interest, like 5% interest, which adds up over time. So I want to send money to this account. So I'm just going to send a very small amount of money. So so this is my main account with the 1400 TES. So I'm going to send, and I'm going to send it to this account that I just copied. If you click on that wallet address, it automatically copies, and you can see the last 4 digits are the same. And then I'm going to send $2. And then I have to confirm. And there, you can see there was like a 1 cent fee. I skipped over that too quickly to show you, but by accident. There was a 1 cent fee for this transaction. And then there was something else called storage that was like more like 20 or 30 cents or something like that. And that, but it said max next to it. It never uses that max amount. It's more of like a warning, like if there's just a ton of transactions happening at any one time, in order to get your transaction through, you're basically saying, I'm willing to spend up to 20 cents, to get my transaction through. But it almost never ever happens on Tezos that you'd actually have to use the maximum. All right, so I didn't even see when that happened, but you can see it took a few seconds, but now I have about $2 or exactly 0.5 TES in this account. And coincidentally, I just got a notification through Telegram on my phone that money was just withdrawn from my wallet in this account too. So there are a lot of scripts that you can use to like track these types of things. All right, so now that I have this wallet, I'm gonna go to Taya, sync. Why does it say not installed? There, okay, I just had to refresh the page. So connect to my wallet. Do I really want to? Well, it doesn't matter. No, I'm just trying to think now. Do I really want to mint with this new wallet that I'm just going to throw away? Probably not. But I think I showed everything I need to show with that wallet. So now that shows how you can get funds in a wallet one way. You can send them from one wallet to another. So it means like if you have a friend who, is willing to share, $1 with you or something, like you can have them send you money if you have nothing in your wallet. If you don't have another wallet that you can use to do that. Since I imagine you're all kind of beginners at this, then that's probably the situation that you'd have to, that you don't have any other wallet. So the other 2 ways, and I go into this with, where is it here? Here, I think, oh wait, where do I talk about it? Not here. Anyway, let me go back to this. That you can, if you go to TZKTIO, at the very top, it says buy XTZ, which is the kind of market symbol for TES. You can buy with a credit card. So that's what I would do. I would just click on this. I'm not going to use a credit card to do this, but you can just basically say like if I bought $10, I get 237 Tezos. And then I press continue, and I would put my wallet address in here and continue. And then you have to go through and, obviously do your credit card and all of that. I'm not going to do that because I have plenty to do what I want to do. But this is how a way that you would fund if you don't already have money in another wallet. The third way you could do it is if you have access to an exchange like Coinbase or Binance or one of those. You can send money from Coinbase or one of those to an external wallet. So you can like buy with a credit card on Coinbase Tezos and then send those Tezos to your wallet. And pretty soon Coinbase will have NFTs on it, so you could just buy the NFTs directly from your funds on Coinbase. All right, so let me go back to here. Okay, so I'm gonna mint another version of this. So I'm gonna go and go to, you can see object. Again, this is like they're still using the exact same word that Hen used, which eventually this has to change. But all right, so let me think. I'm just going to make it similar to the other one. So I'm just looking up the name that I used. So sorry, that stupid Zoom thing at the top that I can't get rid of. So I'm going to name it something else. Rena, I don't know. It's a good name. And oops, I'll just give it the same description because it should all be the same, I think. Okay, let me just double check that the size is that. It's maybe a different 76, 78, 76, 78. Yep. And then put whatever tags you want. And then the number of editions. So you have to be careful with this because you're basically, when you mint something, like if you were selling something normally, like let's say you took a photograph and you wanted to sell it and you only had 10 of those, you printed 10 photographs. You could say I have 10 editions here, and then maybe next month you could make more editions. And then you could sell them, you sold out in the first month and you could sell them more of them later on. That's not how it works here. Think of it more as like these are limited editions. So when you mint something here, you're saying like this forever, this is the total number of editions that will ever exist of this particular image on the blockchain. And if you don't, like if you mint it again, it's kind of called like, it's, well, not, I guess if someone else mints your image, that's called copy minting, and that they're like stealing your work and making a copy of it and then minting it again. And that does happen. That's like the primary issue that everyone's trying to figure out. But in this case, so you have to kind of think ahead of like, well, how many editions is this a one of one edition? Are there only 10 that will ever exist? 1,000? And then you have to think, price wise, what that might be. So I am going to make 200 of them, so a lot. And I will put 15% royalties. Actually, let's just do 256 because I like that number. Okay, so here's where it says, so GIF, JPEG, PNG, SVG, MP4. So yeah, you can have audio and NFTs, WEB, GLB, that's the 3D format, MP3, WAV, FLAC, PDF, HTML, and markup. And a couple of interesting things here. Another architect, Luis Fraguda, who works for McNeel, helps to create Rhino. He and his partner minted a PDF of one of their academic papers recently, which I thought was a really interesting idea. Like rather than like hiding an academic paper behind some like giant publisher or anything like that, they just put their PDF online, and basically you can, if you want, you can read it for free, but you can also like pay for it. And but it's the same content either way. So it's more of like, again, about patronage. Like, is that a really good paper? Then maybe you should buy it and thank them. All right, so I'm gonna upload. So there it is. So when you press mint, it says it'll cost 0.08 TES to mint. So each TES is worth about $4 at the moment. So, you know, not too much. So when I press mint, in a second, I should get a little notification from Temple saying, do I want to verify this transaction? Again, things are always a little slower on Web3 than they are that we're used to for most things. So here comes my wallet coming up and asking me if I want to confirm or not. So you can see it costs one. So the guess was that it was going to cost 8 cents, or 8 Tesos, which is, oh, that was like a, yeah, gas is so little. It's less than a penny. And again, there's a storage fee, but it never uses that full amount. But you can always increase that storage fee as well. And that, like, if you're going after an NFT that's like super popular, and like there are hundreds or thousands of people all trying to buy it at the same time, you can basically adjust this fee, and that basically gives you preference in the buying of things, that your transaction will be more likely to be accepted by the blockchain faster. So it's kind of annoying, and people have written a lot of bots to automatically do all of these things. So for really, really popular things, they often sell out in like 5 seconds, because like a bot has been told, you know, spend up to whatever $500 on this, because they know that it's going to be worth, you know, a few $1,000s later on, so it's worth it. All right, so it should be minted, but another way to check is if I go to my account and I go to activity, you can see that it's still pending about half a minute ago. So when we see this say not pending anymore, it's basically been, yeah, it says now applied, 256 of them. So now I can go back, I can go to manage my assets. It's probably still thinking. So what's happening here is that things are being written to this thing called IPFS, which, what does it stand for? Internet Protocol File Exchange, or I don't know what it stands for, but it's basically like, think of it as a giant hard drive on the internet that's distributed. And your file is going to that location, and then on the blockchain, a pointer to that location is being created that says Andrew Kudless minted that piece of art, and it's being stored there. And that's why if like Taya goes down, or any NFT website goes down, all of the content is stored elsewhere, and it's not stored on the server. So you can see it took a few seconds there for this other one to come about, but now it's here. And if I click on it, you can see that it says not for sale, X of 256. So I can decide to, and you can see I own 256 copies of it. There's only history is that I have created it. And I can swap it. So I can say I want to swap. By swap, it means like put on the market. I'm going to put 100 of them on the market for 0.1 TES, so like 30 cents, you know. So I might change it later, but it's also just like a giveaway, basically. Like, this is, I didn't put a lot of effort into like this particular piece. It's more of like I did it for this workshop. So I'm basically giving it away. So I will then swap, and another little message will come up from the wallet, which I then have to confirm. And then if I go again to my transactions, it says 10 seconds ago that I've interacted with the blockchain with these two transactions. And pretty soon, once that is applied, this will hopefully update soon after that. It sometimes doesn't, and you have to refresh. There. So now it says 100 of 256 editions are available for 0.1 TES. And again, things are slow at the beginning when things have just been put onto the IPFS, this big kind of virtual hard drive that's distributed, because it's only been saved in one location and not a lot of servers in the world are like pointing to it yet. But there's something called pinning, which will help. Like you can basically tell IPFS to like keep that file like available quickly. And a lot of like big like especially on Ethereum and things like that, like all like Foundation and Rarible and things like that, they'll do the pinning for you. On Tezos, it's a little bit different. Some of them are starting to do it for you, but it's more decentralized and kind of if basically what I mean by that is like if something isn't like accessed very often, it tends to like disappear into the internet, and it's basically like if no one's asking for something, slowly it just disappears. So you can make sure it doesn't disappear by what's called pinning, and it will keep it on the forefront, let's say, of that server, so that it's accessible. I haven't pinned this work, and it's also really new, so it's going to load really slowly, and it's also a huge file too. All right. Wow. It's exactly, wasn't planning that at all, but it's exactly, well, it's 2:02 and where I am. So supposedly this is the end of the workshop, but I'm happy to take questions for a half hour because I was supposed to end about a half hour ago to answer questions. I'll look at the Q&A. How did you fix the mesh shadow component for the building shadows? I missed that. Okay, yeah, sorry that little bug happened at all. Let's see, let me just go to. So what was happening was that when I copied something over somehow, if I go to the building detail here, this sun vector, so zoom out, building detail, building shadows. If I delete this, and I'll just turn this off so you don't see it. Well, okay. So what was happening was that it was generating the shadow, but by default, the vector for the shadow is going straight down. So it's like high noon. So basically the shadows were aligning perfectly with the buildings below them. So you can see it says 0, 0, -1. So that's just a vector going down. So what I did was to get the receiver, and then I have the sun vector that I, just so you can see where that is. It was made at the very beginning of the file here with all the other parameters. So I could just change the angle of the sun in X, Y, or Z. And then that's being sent all different places in the file that need shadows. And one of them is this mesh shadows for the buildings, but I hadn't, for some reason, it got missed when I copied it somehow. So now when I do that, you can see the shadows appear. I mean, they were there before, but they were on all the other shadows were using kind of a diagonal vector, and this one was using a different vector. So they were kind of hidden underneath the buildings. All right, so this can only be bought using Tez. Can this exist on other blockchains simultaneously? So not yet, or maybe soon. I don't know. Rarible, which up until recently has only been Ethereum, a couple or maybe a month ago, they made you could buy things with Tezos, but they haven't connected the primary. I mean, there's a lot of different Tezos smart contracts. How do I describe this? If I go to object, so it's a hot collections here. So the Hick at Nunk collection, you can see in the last 24 hours, 20,000 Tez, so 4 times that. So $80,000 have been spent in the last 24 hours. That's not very much at all compared to Ethereum, where like individual NFTs sell for $80,000 or $6 million. So yeah, Tezos is much smaller. The prices are much lower too, and the fees are much lower. The other part of it is that Tezos it's kind of being designed for a different use case in some ways. I mean, NFTs can be almost anything, and like especially for like gaming, where if you're like wanting to buy like some armor for some game that you're playing or something like that, like yeah, maybe you could spend $1,000 on it, but most likely you want to spend like a few cents on it. And it's Tezos has been making they've had a lot of like corporate backing as far as like brands backing them, because brands are like so like a lot of the like sports stuff, like Manchester United is minting stuff on Tezos, and McLaren Racing, the Gap, which sounds really weird. I don't know what they're doing. Ubisoft, the gaming company. So anyway, it's like a very low cost and low energy system, but it's in the last year, it's like just taking off. Like it almost had like no transactions a year ago. And there are a lot of different smart contracts as well. So Hicket Nunk is one of the primary ones. It's the one that's like selling quite a lot because it's been around for the longest, about a year. But there are all these other ones. So FX Hash is the other one that I mainly use. But on Object, you can actually create your own smart contract, and yours would be, shown in, on here like that. So I don't know how to explain it, but NFTs aren't really transferable across blockchains yet. So even within Ethereum, like you could buy something on Foundation and then you could sell it on OpenSea. And that's the same thing you can do now. Like I could buy something on, so even let's say I just go to my collection here on Object. You'll see the one I just minted over on a totally different platform shows up on this platform. And I could, I could buy it on this platform and it will show up on the other platform. So it's more like NFTs are transferable within a certain ecosystem, but I guess your question was specifically about Tezos. And there are people thinking about how to transfer to other blockchains. The problem is like, how much gets transferred? Is it just the image? Like, do royalties get transferred? So if like this NFT, if it were to be now available on Rarible, would I still get 15% of the fees? Like those things, like you have to create like contracts between contracts, and it gets very complex, and they don't all speak kind of the same language, you could say, at the moment. So no, but that's not, it's like you can't buy Ethereum NFTs on Tezos or on Solana or on anything else. Like everything is kind of locked up between these different marketplaces at the moment. I'm sure that'll change at some point because we're only a year or two kind of into all of this. Yeah. Let's see what else. Where do you find the building shadows command? So it's not it's a mesh shadows command. So you find it under mesh, utility, mesh shadows. And it basically, like if I just, I don't know, made a mesh, what's the best way? Where's this? Oh, there's the little mesh. Sorry, I don't need to make it any bigger. Here's the mesh. Here's, and if I grab a vector, here's the shadow of that mesh. And it's going to be a little weird because this mesh is actually not on the ground plane. It's a little bit below the ground plane. So it's creating a weird shaped thing. But if I move this, let me make another box real fast. Okay, so a much bigger box here. And now you have the proper vector. And if I wanted to make my own shadow just really quickly, my own vector, I should say. Oops. Just need a little more room. And I want to create the vector that goes from here to here. And now that's my new vector. So did I do that right? That looks weird. Yeah. It's just, so you can just rotate the sun basically around the object. So obviously there are lots of other plugins and things like that you could use for getting the exact longitude and latitude and all of that to get proper sun vectors, but it's basically just a diagonal between a point in space and the origin, and then you can use that to create the vector. Okay. What impact do you see blockchain technology and NFTs having on architectural education? That's a really good question. Number one, I have no idea. And that is why it's so cool. I just gave a lecture to my students on Thursday about this. And basically, I teach a freshman design media course at the University of Houston. And it's a course meant to introduce students about design media, like all the tools that an architect or designer uses. But it's only 2 hours a week, and it's with 201 students. So it's like, it's not like I can like walk them through something in a computer lab and things like that. And it's also meant to be like half history theory, half kind of practical hands-on tutorials. And I walked them through the history of media within architecture on Thursday, from like just normal, drafting, traditional drafting, to the emergence of like lithographs and things like that with like Piranesi, and the idea that you could actually copy a plan, you know, that you could draw a plan and then have an etching basically made of it, through to photocopy machines and how that affected firms like Archigram and Ant Farm and things like that in the 60s, to the emergence of websites and massive book publishers, so like the mega monoliths, monographs of like Rem Koolhaas's XML or MVRDV's monographs, to like the early websites of architecture firms like Bjarke Engels Group and things like that, of how each generation uses the technology of that generation to do something new with the way that they communicate architecture. And I think, as far as like, so what, the way I ended that lecture was like that it's always the students who, you know, invent these new, whatever technology comes about, you know, like Ant Farm and photocopy machines and creating like little zines in the 60s. They were young architecture students, and so they kind of changed the way that and Archigram was the same in London. So I know how I'm using it, but how it will change architectural education, I don't know, but I'm super interested to see how students think about these things. And I think, for better or worse, and there's just a great essay, I haven't finished reading it, but it was just published last night by what's his name, Ian Bagost, I can't remember how to pronounce his name, but anyway, he has been somewhat skeptical and negative of NFTs over the last year. He's like a media theorist, writer. And again, I haven't read the article yet, so I'm just looking at his tweets of what he was saying about it. But essentially, art has always, in a way, been about money, and the web has always been about money. And there were, and the world is often, you know, as much as we like to idealize it, it not being about money, but you know, it does, it's a part of the culture and society. And again, the way I think about NFTs is, I love that the content is there for free. Like anyone can look at it, can interact with it. But it's like the autograph, you could say, like the certificate that this is made by an artist. That's what the NFT is. It's just a certificate of ownership and authenticity. And I think we often undervalue the work that we do as architects, and we are very good at creating content, but very bad at valuing it. Historically, architects will do whatever they can to stay up all night and spend all of their energy on work that they kind of demonetize their own work in a way, because we often will tell a client, oh yeah, we can do that by next week, and the only way you can do it is if you know, stay up all night. And number one, that has to change, that we shouldn't be doing that. We should value our time, value our labor. And in some ways I see NFTs an interesting parallel to that, that there might be ways that architects could monetize drawings, models, and other things. And you know, Mike Pryor, who, you know, running all of this, I think he's doing really interesting work himself in this area, that like we're all really skilled compared to like the general public in creating content. But for decades or generations, we've been restricted to thinking of that content as the plan sets that are sent to the permitting office, right? That like, that's the thing that gets monetized in the end in architecture firms, that like, we're going to get a building built and get it, you know, permit, and that's what the client is paying for. And that's all good, and that'll still continue to happen. But there are a lot of other ways that I think we can create content and monetize it. And you know, just thinking like about royalties and things like that, like that, you know, you could design a house and you could say there's 100 editions of this house, and anyone who buys the NFT has the right to use these plans for a house. And and Gallo Canizares has done that, and others, I'm sure, as well. But it's a different way of thinking, I think, about how we value our time and labor, and beyond just the traditional like licenses that we're used to creating for our content through contracts with clients. Let me see. Sorry, I'm just catching up here. Is there an option to upload a CAD file or GH file on such platforms? Not yet, but it's an interesting question. So I mentioned Luis Fraguada, I think. Let me just show you his work. I'll just do it here, but see if he comes up here.
I guess you would have to like interpret it. I mean, you can export it as
yeah,
JSON, or just as long as you can. I doubt that, because these websites, they probably don't even know what Grasshopper is, to be honest.
well, that's what I was about to say, that sorry, that Luis, so you can yeah, so you couldn't upload a Grasshopper file or a CAD file, but you can save a CAD file as an SVG file, and upload that. You can save a, so like instead of having an image, if you wanted like the vector artwork of a plan set, for instance, you could save the plan in vector format as an SVG, which I could have done that. If I go back, I'm not going to because it's going to be a huge file, but I could export this instead of as a JPEG, which is obviously a raster file. I could save it as an SVG. An SVG is a web vector file. So it will keep its resolution and all of that. But this is like a really heavy SVG, and I don't know if it would fit. I think it's like a 30 megabyte limit, maybe. It may have gone up since then. But anyway, let me just, I'll find Luis this way. I can never remember people's, so this is Luis Fraguada. So he works for McNeel, and he's been doing a lot of, I don't know if you've all heard of all of the Rhino.inside stuff, but he's been working on that. And one of the ones he's been working on, I don't know if it'll show here. Well, I'll just go to his Taya first here. Sorry, excuse me. So you can buy his work here, and he's doing really interesting things about like geometry that's far from the origin. So I don't know if any of you have had this problem before in Rhino, but when you import some geometry sometimes, especially from like Revit and AutoCAD, when you bring stuff into Rhino, sometimes it shows up like 3 kilometers away from the origin, and like Rhino starts being super glitchy and not working. And it's basically that there's this problem, not just with Rhino, but many applications, that when you have really, really big numbers or really, really small numbers, things don't work as well anymore. So he purposely, like, I think these are scans of dunes on Mars that he imports into Rhino, and then shows how the Rhino model is starting to break down when it gets further away from the origin. Anyway, that's about his work, but his professional work, that's about his artwork. His professional work is to work for McNeel, making Rhino better. And he's created Rhino.JavaScript, I think. Let me see if I can find Rhino.inside. So yeah, so Rhino.inside, most people know about Rhino.inside for Rhino.inside Revit, in that, like, I'm not going to open up Revit right now because it would be forever, but you can run Grasshopper now within Revit. You can run Rhino within Revit, and I've been doing it, and it's really amazing. But you can look at all the different ways that Rhino is being rewritten to run inside of other programs or other scripting languages. So he was actually mentioning to me that he keeps on getting questions about, like, how could you use Rhino through JavaScript basically like you're writing Rhino code in JavaScript, but you get access to all of the same tools that are in Rhino, but just now JavaScript ones, and it could run on in a web browser. So, and you could export the JavaScript, from Grasshopper and other things potentially. So there's the possibility there that eventually, and especially with these hops things that I was talking about as well, which if you search Rhino hops, or Grasshopper, you'll see the developer page about hops, and that the idea is that you could basically be running Grasshopper files in the cloud and anyone could access those. So if that's true, then like potentially you're actually selling Grasshopper files as NFTs eventually. And that's a little bit what Hypar, let's see if it's this one, hypar.io, yeah. So Hypar is a cloud-based modeling, building information modeling, I guess you'd call it, application that is all in the cloud, and you can write Grasshopper files for it, and it allows you to create cloud-based Grasshopper files, let's call them, that can then be reused by other people in their own files. But it's basically you write, if I go back to Grasshopper here, Hypar, you can see there's like all these different ways of converting your Grasshopper files into code that Hypar will understand, and that then Hypar is creating kind of like a marketplace for cloud-based things. I don't know how they're monetizing any of that yet, but I think the idea is eventually there would be a marketplace, and that you could, as like a computational designer, like write scripts that would create a facade system of some kind, and then firms could pay to use your script and you would get royalties from that. Coincidentally, Andrew Human, who created the Human plugin that we were using today, is now one of the main developers for Hypar. Do I teach any other online courses throughout the year? Sometimes I do. I haven't usually, I haven't in the last couple of years. Usually I teach workshops in person, and then I teach a lot, just at the university. But yeah, maybe I'll teach some more this year.
Maybe we'll have to get to do some more.
Yeah. Great. Could you please explain the thought process in the wall crypto city from the presentation for the allocation if the different types of buildings is on each chunk of the wall? So I'm not sure I understand the question, but I'll go to that. So basically it's one giant beastly Grasshopper file where once the big ribbon is created, it gets subdivided into by length. I don't know how many times, but like hundreds of times. And then randomly those segments are assigned one of the 26 letters of the English alphabet. And then I wrote 26 different functions, basically, or groups of code that produce the yoga mats or the Zen garden or the, I don't know, ice skating rink or whatever it is, Christmas tree, or exhaust fans. Yeah, I don't remember all of them. Antenna. So anyway, so it's basically like a very big Grasshopper file that just has like 26 little chunks of code for each letter of the alphabet, and then those are being assigned different polygons to be deployed in. Oh, what is the name of that theorist? Let me look him up on Twitter. I was saying, I just started to read through his Ian Bogost, not sure. But it's in the I think it's in the Atlantic, I thought he said. Let me scroll down to, he tweets too much. Here it is. The internet is just investment banking now. I like if you just look at the tweets that were here, isn't it? He had a tweet. There it is. Okay. So there, yeah, there's basically in the last couple of months, there's been a discussion of like, are NFTs art or not? And the Wikipedia editors came down on the side that NFTs are not art. I haven't really thought about it enough to decide if I think NFTs are art or not. I think NFTs are just a contract in a way, I think. On one hand, like they're just a contract that says someone owns something.
Yeah, I'll just like, I think like the general public that knows about NFT, like their kind of ideas, like NFT means like a picture of an ape,
Exactly.
But all NFT could be anything. It's just like that's what's popular, like the popular use for NFTs right now is like these kind of like animal drawing images. But all NFT is just like you just tokenize something. Like you just
Exactly.
that's all you did. You just put something on the blockchain. It doesn't have to be an image. It could be anything. Like even Andrew showed there was a PDF of something there. So you can put anything as an NFT. All you're doing is just tokenizing it.
Yeah, and I think it goes back to like what I was saying about like that student who didn't want to use Grasshopper because he didn't like twisting towers. So like a lot of people don't like NFTs because they don't like Bored Apes or whatever. And it's like it's just like such a stupid argument in a way, because it's like there's the things that are popular now and that has a certain style to it, but that doesn't really have anything in a way to do with the technology. They're two different things. And I think yeah, it's just a contract that is, and so you can do anything. It doesn't have any style of artwork. It could be music, it could be text.
But
It
just
doesn't
a
really
new thing
matter.
now. Music is a big thing happening now too with NFTs.
Yeah,
Like artists are putting out their own albums by themselves as NFTs,
totally.
and
Selling tickets to concerts,
making way more money than they would with like
Spotify.
Spotify or even like a label, like a label,
Yeah.
or like they're getting a few like pretty well-known artists, like they're kind of like off the top of my head right now, but like hip hop artists like
Yeah.
released like I don't know 1 million of them as NFTs, and then like they sell out instantly, and basically they get the money, like right, like to the labels, not so again like independent kind of stuff. Um, so I could see so many things happening in NFTs, like car titles,
Yeah. Deeds to
loans, housing
houses.
deeds. Yeah, I mean
Yeah.
it's
I mean, I
because
think
it's
that's
just
one
a
of
way
the,
to keep track of everything, and you can't really like lie on the blockchain, So
well, I mean, that actually goes to the next question there. Can we upload the same artwork on various NFT platforms?
yeah, so
So
that's like technically yes, but
sure, you can totally do that.
it's like pretty frowned upon.
Yeah.
Like people like you'll probably get, because if you tokenize something, it should be like that's the thing that represents that token.
Yeah.
So by doing that, you're basically saying it's actually not rare or not
Yeah.
specific, like you're putting it as multiple tokens.
The equivalent, I guess, would be if like you were a famous photographer and you said, okay, I'm going to make 10 prints of this photo, and I'm going to sell those 10 prints. And those then sold out. And then you said, oh, actually, it's not a limited edition of 10. It's actually now a limited edition of 1,000. The original 10 collectors are going to be super mad at you because they're like, I bought that photograph when it was one of 10. And now you're saying it's one of 100 or one of 1,000. So it's
Or
basically
or
a
it's like
way to,
selling the 10 photos to 10 people, but telling each of them that they're one of one.
yeah, exactly. So you're like lying and you're going to piss all of your collectors off. So definitely don't mint the same artwork on different blockchains or even on the same blockchain
The only
or the
time
same market.
the only time it's okay to do that is when it's like a collection mint, like a collection token, like
Yeah,
how Andrew just did. Like he minted and he specified that there's 50 of them or something, or whatever.
right.
That's when it's a collection like that, then it's okay.
And that's like the normal, like an edition of photographs. Like it's a limited edition. It's the same photograph 10 times. Yeah. So what was I going to say? But it does bring up the other question, is that what's preventing other people from doing that to your work, right? Because I could like go to any of these images. So this is now Versum, and I could right click on the image and save image. And then I could upload the image as if it was mine and try to make money from it. And this
Which you probably
happens.
could from like a naive person, like,
Yeah. And
and
this
it
is a
could.
huge problem. It's
I
called
started making stuff. I started making stuff with Wilder World in like the first week. I already had someone like with a fake account in my name.
wow.
Um, and but at the end of the day, it doesn't really matter because the real like the actual people that know will know. Like you can see what's kind of
Sometimes it's been a problem on FX hash, which is like the,
yeah.
so it's similar. So art blocks, let's go to that. Art blocks was kind of one of the first to create like that. You'd upload code and then artists collectors could like the famous one, the most famous, well, I guess there are two that are really famous. Fidenza by Tyler Hobbs. Wow, there's been a lot. I didn't realize they.
That's why it's kind of like the for instance like the NFC stuff I'm working on now with Oleg. It's like um they're like metaverse assets, 3D. Like you can't right click save them, so
No.
um and you can't really even like download them and sell them
Hmm.
somewhere else, like that's a kind of. So
But I'm sure
I don't really have
eventually.
that problem. But the funny thing is like the fake one that I said, like they took like teaser images. So like they're not actually copying NFTs. They actually just took the images and made like NFTs
Hmm.
of
Oh,
images of
weird.
things that are meant to be 3D metaverse
Right.
assets. So it's like a kind of different kind of copying.
Yeah. So it tends to happen less. I mean, it's kind of like galleries in a way where it's like if like art blocks is like very high end, like things will all sell for like thousands of dollars, if not millions of dollars, kind of. And so like you can kind of trust that thing, and it's also curated. So like the people who are minting on this platform are only a very select few are allowed to mint on the platform. So they don't have any problem with copy minting in a way, but someone might say, oh, I kind of like this image and I'm gonna like save this image and then upload it to OpenSea and treat it as if it's my own. But very quickly, usually people discover that. And but it also, it's like it's up to you to do your research. So a lot of like on FX hash or on so I'm trying to see. So any of the ones that have the little check mark next to their name have been like verified that that they've been on the platform for a long time. They're not copy minting. They're not like, it's been verified with multiple other, forms of identification and things like that. So it's like
That's true.
more trust, even though anyone can mint on the platform, it's like you can
And
kind
every
of trust
platform
these.
has that.
Yeah.
Like, so if you're using a platform, you should go through that process. It's usually like linking your Twitter and sending some kind of email, and like
Yeah.
there's a process. Each one has its own process, but it's not it's not lengthy, but it's difficult for like someone who's not you to pass. And also I would be like weary of buying from people that aren't verified because
Yes.
it's so easy. Like it's so easy to verify and quick if you are like an actual person that does that work. That anyone that's not doing it seems kind of a little suspicious, in my
So
opinion.
yeah, definitely. But it's like there's this FOMO where like, especially like on FX hash over the last couple of months, like Casey Rees, who invented processing, we co-invented it. He out of the blue created 1,000 generative tokens of this super simple, very simple artwork, but he was just like stepping through the history of art and recreating kind of inspired pieces. This one, anyway, within a day, people had created unverified accounts but had the same exact name,
Yeah.
like but like with weird spaces or something afterward, something like that.
Yeah.
And people are like, oh my god, it's him, like, and buying it immediately without thinking about it and doing the research. So there have been some cases here. I don't think I've ever bought anything that was copy minted, but some people do because they just don't want to miss out on something before it gets sold out. And you just always have to step back and be like, it's not worth it. Like you can, prices fluctuate. You don't have to get it the day of, you can get it a few days later and it's probably not going to be crazy. But I mean, what's kind of interesting though, like if I go to the marketplace, like it does, FX hash gives you more information about that, of how the volume has changed over time or the floor. So, it did start out at, well, actually started out at like 1 tes. I don't know why it doesn't go back any further, but it stayed pretty constant for the last couple of weeks. So things like it, there are, I don't know, getting kind of off track here, but it's like,
I was asking, what is the pros of Taya instead of OpenSea? Well, cost, I think, is the big pro, right? I mean,
totally. Yeah, I mean, I haven't
because
tried minting
OpenSea
art.
is like OpenSea is the most popular thing in this kind of art NFT, I would say. But OpenSea
Yeah,
is Ethereum, which is expensive.
yeah. I mean, you can just see the prices are astronomical, right? That the floor, which means the lowest price, is around 10, which times, I don't know what the current price is, 33,000 something. I don't know.
Well, you can see there's Bored Ape, right? Bored Ape is right below.
Oh,
Ape,
yeah.
yeah. 100 ether floor.
Yeah. So anyway, it's like
but
some of the
gas
prices
is the
are,
big thing, right?
yeah, the things are very both the prices are higher on Ethereum, the energy use is higher, and the fees are higher. It all goes kind of hand in hand in some ways, but it's also really popular. It's like probably, I don't know, 50%, and that's just like a wild guess, they're probably sold on Ethereum. But there's lots of other ones, like all the like sports stuff is not on Ethereum, I don't think. It's all on like Flow or Tezos or I don't know, some other weird one. So like not that many like companies are jumping into Ethereum, I feel like, as much just it's because it's really expensive and risky in some ways, in that way. So it's some of these ones that have like much lower transaction fees are picking up, I think, some more, but who knows, within a year, hopefully Ethereum will be proof of stake and things will have much lower fees, but maybe not, you never know. All right, so which was the name of the app used to create smart contracts? I don't know if I mentioned an app to create. Oh, well, there was Object, object.com, where they created their own kind of unique minting process. So originally they were just a clone of Hen, and they then develop their own contract where you can, I go to create, I haven't done this, but basically you can create your own collection, which ends up kind of creating your own contract in a way. So it's like, it's hard to describe, but it's not really, I mean, it's just like they're using a template for the contract and just changing a couple of things. And then you can sell, lots of tokens within that one collection. So it's like, I would say it's mostly for things like I don't know, all of I always forget the name of it, the profile stuff. What's it called? The PF.
PFP, profile picture.
Yeah, thank you. Profile picture. It's mostly used for that. So it's like, it helps differentiate and say like, I'm going to have lots of different things all within this one collection. As far as writing other smart contracts, I haven't done any of that myself. There's lots of in Tezos, there's like a whole Python.
Smart contracts is like a whole job. I mean, I've seen companies hiring smart contract developers for like 7 to 8 figure salaries. It's like a very complex thing, but also like you're like, if you screw it up, like you can really screw up majorly, right?
Yeah.
You're like screwing up everyone's money and this. I've seen like some projects like the contracts messed up, which like had exploits and allowed people to like buy and mint things for cheaper than they should, or like duplicate and sell things. I mean, it's got to be airtight.
Yeah, I mean, that brings up another thing that is important to talk about, that is a big difference between Web 2 and Web 3 things, and that, let's say, I don't know, Apple or Facebook or whatever, they mess up something, like you can sue them, right? Like there's like ways to like legally deal with companies, but blockchains are different in that they're not really owned by anyone or controlled by anyone.
Like if you get your money taken or send it to the wrong place on accident, or send it to Andrew's dead wallet there, it's there's nothing you can do about it, and no one can do anything about it. It's just, it's gone basically.
Totally.
And you can see it there, gone in the abyss,
in the transaction.
Yeah. But you can't nothing
actually
you can do about it.
But so it's called, I mean, what's related to this like both the mistakes and the exploits of code, it's referred to in the kind of Web3 world as code is law. And it's a really tricky, ethically complex idea. That the idea is that whatever is possible by code, like if your contract has a hole in it, like you forgot about something, like, and someone exploits that, there's the idea being that like, well, you didn't write the code right, so you get exploited, that's your fault. Whereas in the real world, let's say a contract wasn't written correctly and someone exploited it, but was doing it in a way that got around like the kind of overall ethical meaning of what the contract was about, like you can sue that person. Even though there was like, maybe it was like the contract wasn't quite right, there's still ways to like fight that. There's like no way to fight it in Web3. So it's like super risky. And that's why people would be, paid 8 or 9 figures a year for writing these. And because it's like so many companies have just gotten totally destroyed by someone finding a bug in the contract and then stealing millions of dollars. It happens like all the time.
It's so common. And so actually, Michelle's asking about because Arturo minting on OpenSea, and yeah, I mean the reason people use OpenSea is because like, so OpenSea is and Ethereum is right now, it's like a big money game. So that's where like all the humongous sales are made, but it also takes money and risk to be in that game, right? So like, you know, and that's what all like, for instance, like Foundation and all these kind of like known origin and super rare and nifty gateway, all those kind of like big kind of players are all kind of attached to Ethereum and OpenSea. Rarible too, I think, also is OpenSea, on OpenSea. And so again, it's like bigger amount of money you can make because it's like it's more popular, and you know there's a lot of people with Ether, but you know, like for instance, like minting, you can spend like, I've seen it even as high as like $700-800 just to mint on Foundation at like at like high points of the gas transactions.
Yeah.
So you have to be pretty sure, like, and pretty confident, like you're gonna make. But again, like with the board, like for instance, like with the Bored Ape, or like you know that you see that blue one there, the blue face thing there. Those things sell for so much. This, I forget her name, but she sells like so much, like crazy. And why they're like, look at that. What is that? 50 ETH? Is that 50 Ether or 5 Ether? Can't see.
I'm not even sure how to. Let me just go to.
Anyway, so like, you know, to spend
just 3.
$800 in gas is nothing when you're like, you know, a Bored Ape, you know, sells for like the cheapest one is 100 Ether, right? And people are buying them too. Like, was it Justin Bieber just bought a Bored Ape like over the weekend for $1 million and a half dollars in Ether, right? So it's just a different game, right?
Yeah, and
that's
like
the
I
thing,
said
man.
before, like I'm not. I don't know. My primary goal isn't making a bunch of money in this either. So I went to where like my community was, in a way where like I had friends who were also on on Hen originally. So it was a way for me to like, rather than like double clicking on an image they would put on Instagram and feel like, oh, good about myself because I like liked their work. I was like, you know what? I like their work. I like their work enough where I want to like give them a few dollars, and like, and if enough people do that all around the world, then maybe they'll make something. But it wasn't like
Karsten on FX Hash, he dropped, he made like, I think he made like 50 grand or something on his first drop on FX Hash.
And I was part of it. As soon as I was like, yeah. How do you spell his name? K-A-R?
K-R-S-T-E-N. Karsten.
No, it's
K.
Let's see. Why can't I find this stuff? I'll find it this way.
Toxie, Carson. Yeah, there you go.
This is not his. So
that looks like yours almost.
Yeah. I don't know why. Yeah, people don't put. I can't remember what it is. Oh, it's Toxie. That's why.
Yeah.
It's like so hard to remember people's user.
Yeah. No, I used that because he made toxic libs.
Yeah.
I don't know if you ever used toxic libs.
Yeah, yeah. So this is one I own. And yeah, he created 512 and each one was 32 TES. So at the time it was around, I don't know, it was like $150 or something like that that I spent. And it was crazy though. It was like it went up to like, I mean, now it's at 100, so like $400 per edition. But at one time it was like 800, and you can see that, yeah, on the initial sales he made 16,000 TES. So depending on the day, 4 or 5, 3, 4, 5, up to 9 times that amount for US dollars.
Yeah.
But then it's made
I
an
saw-
additional 16,000 in secondary sales, and he gets, I think, 20, I don't know what the contract says here, 10%.
It's funny because he was at, he was working at Nike, and he left Nike, and then he did this, I guess, like a few months later. I mean, he basically made a year's salary with the 500 images.
And I really respect what he's doing, because he's done like, whoops, where is that? He's done like only 4 pieces, I think, so far. Yeah. So if you click on, yeah, just these 4 pieces, each one is sold out. And he keeps on putting the price higher and higher, and they still sell out. And but each one is like this, like he talks about the history of the algorithm and what's happening and how this, and he's been, he gives back so much through his library.
Yeah.
That, for 20 years or something almost, that he's been creating code and open sourcing all of it to create various structures. So it's very cool. As soon as I saw him on this, I jumped on it, and it was, what was really great was like, so this is, it's a never repeats. It's not a GIF. It's all code, and it never repeats. And my daughter and I watched it for like 10 minutes, and it was like this like guessing game of like, oh, what's going to happen next? So I think, oh, it's going to come in from this corner, and we can never guess what it was going to do. But it like kept our attention in a way that I think a lot of art on any of these platforms can't. And it wasn't just that it was interactive, it was, or not interactive, it's animated, I should say. Anyway, he does really amazing work. I'm not sure why it's not showing full scale though.
So it never repeats ever?
Never. You can run it for
But does it,
forever.
like if you close the page and open it, does it like take a break, or is it just going like you miss stuff if you're not looking at it?
No, it's cooler than that. Every single one that's been purchased is a unique one.
Yeah.
So if you so like if I go to the, not market, sorry, scroll down. So these are all the ones that have been made, of 500 something of them.
Yeah, but like, so if you open one and watch it, it never change. I mean, it never is repeating. Like it's not on a loop.
It's not on a loop, but if you close it, I guess you're right. Yeah, if you close it and reopen it again, it'll start from the beginning. In that it uses your wallet, like a hash from your wallet, to like initiate the code. So then it will start going, and then it keeps on going with that. But yeah, if you open it again, it's always the exact same.
Did you see the OG Crystals project?
No.
That one was really, it was on Ether. I'll put it here. So I had one of these, which was cool. So you bought like, and their website's really cool too. So you bought the crystal, and then every time it was traded, bought, or sold, like the crystal would grow, and the growth was depending on like the two transactors, like wallets, how many NFTs they own, like what, like all this kind of information. And it was kind of cool. Like, so like me and a few friends that had them, we were just like trading them back and forth, like around to each other, like so that they would grow into these big. So every time you buy it, you're not, the one you buy isn't actually what you get. You get like the next, like, so if I bought 2, I would actually get 3, like the number 3 there,
Right.
because it added like a growth, you know. So that was like that was a really cool system, that I thought that was a really interesting one to me.
Yeah, there's, I'm gonna try to find a couple similar ones.
Oh yeah, if you
Around-
would have went down like one scroll, you
Oh.
would see like the yeah, you'll
I
see
see.
like, oh yeah, see,
Yeah.
like,
Yeah, so there are a lot of interesting ones that are emerging. So this is where it goes back to the are NFTs art in a way that on one hand they're not. It's just a contract, but on the other hand, there are other, like, there are things that are hard to describe without saying it's an NFT and it's art.
yeah.
You know, that it's like that this is interacting with the blockchain and changing over time. And the one that I was going to show on Versum.
It was kind of cool. One funny thing about that project is they embedded in the logic, like you couldn't, if you just like, because first we're like, well, what if we just like send each other's NFTs without paying money, so like to grow it. So it was like if you did that, it would make your they put in the code that it makes your crystal go black,
Shrink.
like it loses all its color. So it's kind of like, it was kind of funny. I think a few people did it and like their crystal turned black, and it was kind of like a marker, like that they try to cheat the system or something.
Yeah, there have been a couple of ones on Hen like that too. That and this one, this is a little bit different from that, but this one where it's basically like a digital loom where every day another kind of stitch gets created.
Cool.
But that it'll end in the year on the 31st of May 2163. And then there
No
were
one's
other
even paying
ones.
attention to it anymore.
Yeah. Let me see if I can find the other one that
Yeah,
I
maybe
own.
after that one we should end this thing.
Yeah, we
Talking
probably
for a while.
should. Oh, sorry. It might take too long to load, but
Oh wait,
there
isn't that,
all these like conceptual ones
that's
are
Mario's there?
what?
That white donut was Mario's.
Oh yeah.
Solid Buckets.
Yeah, I tend to collect a lot of more architectural things. So yeah,
Was this
almost
your collection?
this is what I've purchased. Yeah.
Oh, okay.
Or some of these, I think someone maybe sent me this one. I don't know, and definitely this one, someone sent it to me for owning something else. But trying to find one where it's like going back too far in time. I don't think it's that one. It's hard to describe, but it's like if you sell it, it like or it's like an image that the more it gets sold, the more it gets erased. I think it was pretty early on. It's not loading fast enough. Anyway, yeah.
There was, yeah, I mean, there was another project I saw that was interesting. Was like you can buy like these kind of like communal projects, like
Yeah.
it's like one image, and then people can buy rights to change things on that image. Like you
Yeah,
can
I remember
buy the
seeing that.
rights to change the contrast, for instance. And then so like you can then set the contrast, and someone could buy rights to change the hue, change, like this kind of thing. So I thought that was kind of like cool too, because it's like, a few people owning the same image, but each person has like different control over some part of it.
So this one is like Unity, that you can actually build a 3D model within
Oh,
it.
that's cool.
And
That's fun.
it Yeah, it's so this is Alex Grasser I had mentioned earlier, architect. Where did it say here? Assistant professor at the Institute of Architecture and Media. I'm not sure where that is. Anyway, he's created a lot of really interesting ones where, I mean, this is just a video of it, where like multiple wallets are interacting with the digital model at the same time and like co-creating it.
Mhm. So,
Um,
yeah. So yeah, I mean, there's just so many things you can do that aren't just
an image. Yeah,
pictures. Yeah, like a
totally.
to make
Cool.
fun
I don't
activities.
know if we
Cool.
answered all the questions, but hopefully we did. And if
I
not,
think
just,
enough. Yeah.
yeah. um, cool.
Cool. Well, thanks everyone. Thank you, Andrew. Just
Yeah, my pleasure.
nice workflow and insightful for a lot of people. And yeah, and for everyone that's still here, thanks for staying for our conversation.
Yeah. All right. Well, have a good weekend. Thank you, everyone. And yeah,
Also,
good luck creating your own.
yeah. See you.
All right. Bye-bye, everyone.